Good morning. Guys here all right? Yeah. How are you guys doing? I heard a lot of people are sick. Yeah. How's the PBA experience so far? Bali is beautiful, no? Cool. So I guess now we are gonna get into a more meaty content of PBA. We are gonna start building your own blockchain. So that's exciting. Um, uh, there's a lot of content to cover in this week. I might go sometimes very fast. Feel free to stop me. If I'm going too fast, feel free to ask questions. I'd like to be more interactive. Um, and yeah, also I'll introduce me and my colleagues who are going to teach you. So I'm Ankan. I actually was a PBA student when I started with my Web3 career. And yeah, I joined Parity since then. And then this is the second time I'm teaching at PBA, which is, I'm very excited to teach. I have also my colleague Alex that is back there if you guys want to see him. There is also Cisco and Sean. Sean is here. Sean, you guys. Yeah, we will be the guys who you will have to tolerate for this week. Okay, to start off, I wanted to just kind of also give you my reasoning, my why of why I'm in blockchain, why I'm, a Web3 developer. And what I believe is blockchains are fascinating. If you think about, look at the history of humanity, every time we needed to coordinate on scale, we needed some middleman or some central authority to trust to make sure they enforce the rules that we all play nicely. Think about your bank. You keep money there, and you hope that when you want it, they will give you back that money, right? You trust the police to enforce all the rules in a country, right? You send a text message to your friend, and you trust WhatsApp to deliver the content without altering it, right? And for the first time, blockchain, like as a technology, enables to do all these transactions, to exchange value, to coordinate on scale without trusting anyone. And I think that's fascinating. I think we are still like at a very early stage of blockchain and our understanding of what problems we can solve with this. So what has this technology kind of enabled? It has given us Bitcoin, which is started off as a medium of exchange, but it's called now digital gold, right? But it's interesting. It has same properties as gold. It's as durable, I hope. It's as scarce as gold. We have Ethereum that kind of pitched that they wanted to be a world computer, right? So it's like a computer on the cloud that nobody owns, but everybody verifies. You put some program on it, and you can be sure that it is going to be executed as you intend it to happen, right? There's programmable money. You can now program value to work, to design it the way you want it to be. Yeah, so I think we are just still scratching the surface. We think of how to program money with blockchain, but I think there's still a lot to learn. We are just like 15 years young. Imagine 50 years. Like our understanding of blockchain primitives, how we will use it, is still evolving. Most people don't even understand the pitch. So yeah, but then let's say you have an idea, you have a vision, you want to build something with blockchain. How do you do it? Turns out blockchains are very hard to build. Actually, it's not just engineering. It's like roughly 8 disciplines that you need to be expert in. So there's like networking, how your nodes communicate with each other, how your signatures are work, how all these nodes come to consensus. the database you will use, the execution VM, the tokenomics, how do you upgrade the chain, how does it evolve, the dev tooling around it. So it's hard to build. And pre Substrate world, when Substrate I think was launched, there was only Cosmos SDK maybe. So pre-Substrate world, how do you build a blockchain? You either fork an existing blockchain, you take Bitcoin or Ethereum and you modify it, but that has also its own problem. You inherit a lot of technical debt. You have to keep updating with the upstream. Okay, but you can make it work, or you build from scratch and you master all those disciplines. You try your best. You work for, I don't know, 10 years to build your chain, and maybe you will succeed. It's a very less chance, right? And even if you build your blockchain, one small bug could lead to millions or billions of dollars in value lost, right? So there's been examples. I don't want to go too much into it, but in the slides you can see, and there's like links to the bugs. But yeah, we have seen a lot of bugs in past. Even Parity's wallet was hacked, and this like 115 million at the time in 2017 worth of ETH is frozen permanently on chain. Probably it's way more value now. Right? Solana has been halted like 8 or 9 times since it's launched. It's been pretty stable for last year, but yeah. So building blockchain is hard, and so what can we do? I mean, what can we do something in between? So imagine having a SDK or framework that is like Legos, where you can pick and choose what you want in your blockchain, and you specialize in the things that you want to make a difference in. It could be your consensus, it could be, I don't know, your business logic. And that's just the idea of Substrate. So the core thesis of Polkadot, how it started, was that we believe that the future is multi-chain. There will be multiple chains specialized in its own thing, and they're talking to each other very seamlessly. So as part of building Polkadot, we decided that we will build Substrate. And Substrate kind of allows you to almost do everything. Basically, you can choose pieces. I will show you like more visual picture of all the components, and you can pick and choose and build your own blockchain, specializing only in the things that you want to, right? Few examples of chains that are built with Substrate. The Polkadot relay chain is Substrate based. Moonbeam, which is like totally different accounting scheme than Polkadot. It uses the EVM addresses. There's HydraDX, which modifies the transaction pool and how its business logic works. There are 100 plus parachains today. There are also, you don't have to be built only on as a roll up on Polkadot, right? You can take Substrate and build your own standalone chain, and there are a few good examples. There's BitTensor, which is probably popular right now. There is Midnight, Cardano. They are using Substrate to build their own roll up, I think. There are a few more examples. Starknet is like a ZK roll up on Ethereum. Yeah. We also decided, I think we were one of the first to choose Rust for our blockchain. I think before that, Golang was used a lot. And now I think Rust is very, very common. And I mean, I could find all these reasons to why we chose Rust, but the biggest, I think, for me is this secure 70% fewer bugs. And I think in 2 separate talks, a Google engineer and Microsoft engineer in some security conference have claimed that 70% of their bugs are memory related bugs, right? And that comes actually from they using C, C++, which is very fast, but we make they there are bugs that comes that we are not always doing it right. And the second thing is Rust, while being memory safe, is as fast as C or C++. So this is why, I mean, we started with Substrate and what it stands for, why we believe it's one of the best framework to build blockchains with. But we learned, I mean, I think Parity worked a lot with Ethereum before, and we had a lot of experience building blockchains. So we wanted to also improve on previous stuff, and few things where I think Substrate was kind of trend leader, or they innovated a lot. Was okay. So think about how your chain upgrades. All these nodes that are coordinating together. You release an update. You set aside a time, and you convince all the nodes to go and update this software at around same time, and you hope that everybody does, right? If they don't, if let's say only 50% updates their software, you have a chain split. Half of them on another fork, half of them on another fork, right? What Substrate does is, so I'll go more on how it works, but what Substrate does is the code itself is part of the state of the blockchain. As in, so when a block comes, so the way the upgrade would work, you propose some code block that needs to be that change should be upgraded to, and some governance like reviews, it gets accepted, and at the time of the block when it should be updated, every node by like automatically updates it to that software. So there's no fork. So this is a very simplified architecture of how a Substrate node works. You have a node like any other blockchain node that other blockchains have, but there's this runtime layer, which is kind of embedded in the node, and node is kind of doesn't understand runtime. For it, the value, everything that it deals with are like opaque values. And to understand or make sense of anything, all these things may not make sense completely, but hopefully as we go and repeat all these things, will start making more sense. But there's a runtime that talks to this node. In this context, you can call it a host. And this runtime is your business logic. The node is things that are not really your business logic, like the networking, the consensus and stuff. You don't have to care about it. What you care about is the runtime, and that's your business logic. And that can be updated on the fly. Yeah, so to go over again, so there's runtime, which is your application logic, which is stored as part of your chain state, which is why we can update it on the fly. This is the STF that you might have heard before. And then there's the fixed node. And a really good example of this, I think maybe Sean came up with this, is that let's say there's a gaming console and you have the hardware, that the gaming console in which you put the game disk, right? So that gaming console is your node, and the runtime is like your gaming disk that you can change and update. So how does the forkless upgrade happen? So this is your blockchain state. And for every block, there is some state, some Wasm code block that you upload in a executor, and you run your business logic on it. And let's say now at the n+1 block, you want to update to a new runtime logic, right? So by this time, a new Wasm blob is already proposed and executed at the end of this block. And by the next block, this runtime 1 is replaced by runtime 2. And the next time we upload, we start a runtime executor, we upload the new runtime. So I did lie a little bit. It's not always forkless. There are situations where we will have to update all the nodes. And maybe you can already imagine what those reasons are. So the way the runtime and the host talks to each other is via some interfaces, right? And when those interfaces break or something changes, right, uh, you need to update all the nodes. And everything else, it can be forkless. And there's a link actually in the speaker notes, and you can see that there has been 65 times, probably more now, that Polkadot relay chain has been upgraded in 3 years or 4. Oh, 5. The other thing that we wanted to, or it was important for Substrate, was figuring out how the upgrade, the governance works. So how does the evolution of a blockchain happens, right? And so we decided we wanted to have governance baked into the system, which means there is like a very advanced way of like voting on referendums that can be proposed on chain. And these reasons could be how you manage your treasury. Every substrate chain can have a treasury. How do you configure the values of, I don't know, like some settings of your chain? How do you upgrade your runtime? And so now we look at the whole picture. What Substrate gives you is like very modular way of building a blockchain. You can replace almost every component with your own custom thing. Today, like database, you can have ParityDB, RocksDB. You can have different ways of networking, consensus, finality. And these are not just all, like you can build your own thing. Almost at every layer of Substrate, it is replaceable. I think it was also very important, so we are kind of future-proof. It also adds more complexity, and we try to solve that in some different ways, but yeah. At the core primitive substrate level, you can almost swap out everything. This is a bit more advanced or better like substrate architecture. Everything outside the runtime is like the node part, and everything is like opaque value. So when you see the database has this some random hex codes, it's because the node itself does not understand those values. They are like just bytes. And to understand those values, it has to talk with the runtime. There are a lot of other layers, and we will actually go through a lot of them. Probably you have already went through a lot of them in fundamentals. Yeah. So yeah, to recap, Substrate provides a very modular framework to build a future-proof, fast, secure blockchain. A lot of these components can be battle tested, and you don't have to worry about something going wrong. You only care about something that you want to change. Yeah. So this is the end of the lecture, and I'd be happy if you guys want to ask question. And I also say, I mean, this Polkadot SDK repository is pretty heavy. So if you guys don't have already, you can clone this. You can compile it. It will probably take a lot of time. We are not going to touch it today, but tomorrow we will start like just showing you the code, how to understand and read it by yourself. It has few components. Again, I will go through it again, but know that I have not covered few things like Cumulus and XCM and Frame will be covered later in this week. Yeah, any questions?
Hi, good morning, Scott.
Yeah.
It's more curiosity. How do you test it? Because I mean, this is like distributor thing.
Yeah.
I'm curious, how could you like test, roll back, like stress test,
Yeah.
without messing around too much?
Yeah. So there are multiple layers of test. You can think of it as just one single computer and test it. So we have the unit testing framework where you can have, we emulate the external storage, and you can read write like it's a key value database, and you can do things, right? So that's the unit testing level.
More higher.
Yeah, more high.
Yeah.
So there's also something called zombie byte or zombie net, and there are like variations of it where you can simulate multiple nodes that are running. It's almost like a Dockerized kind of thing. So you say what kind of setup you want. It starts with that. You have some genesis state, and then you do things on that. So you can write your own like testing framework where you interact with the nodes, do something, and hope everything is like valid. So yeah, almost similar to how you test your Web2 backend.
All right.
Hi, Luca. Here.
Yeah.
ParityDB, it's based on level DB, right? Or is it something wholly new?
I'm not sure actually. I think it's completely new, and we tried to optimize for the kind of key value pairs, like small values of data, small size of data. But I don't know if anybody else has a good answer to it.
Also remember it being custom built, and then it's probably inspired by other databases that the developers were familiar with. There's probably inspiration there. I don't know whether anyone can talk to it.
Yeah, I think Rocks.
Yeah.
Yes. Sorry, what was the answer?
Yeah, fundamental design is based on RocksDB because that's why it was chosen, because it is in the right direction. But then there were like, it's interesting actually to look at the ParityDB. Like it has a nice description, like, hey, here's the trade-offs that we made differently than RocksDB, and that leads to different performance characteristics.
Hi, Lynette here.
Yeah.
My question is, are cryptographic primitives part of the host or the runtime?
Yeah, so cryptographic primitives are expensive, so they need to be part of the node. But then there are APIs, the host APIs, through which the runtime talks to use these primitives, right? So they actually run on the native code. Does that answer your question? Just to expand on it, I mean, we do a lot of this serializing, deserializing, right? When we are talking, the runtime is talking to the host. And if we do it on the runtime level, it'll be very expensive, and we are trying to save cost.
You said that Cosmos was already there when you guys started building. Like, what problems did you see that Cosmos was not able to solve when you built Polkadot?
Yeah, I mean, I'm not the expert. I have been only 3 years into this ecosystem, but what I know or understand, I don't think it was already built, but I think it was launched at least a little bit before Substrate. So I'm guessing there must be overlap time where they were both building in parallel. Yeah, I don't know too much about Cosmos. I think though, I mean, the biggest choice is Golang versus Rust, but also I would like to believe, without a very informed opinion, that I think Substrate is way more modular at the cost of some complexity, but it's like extremely swappable at every level. I probably think Cosmos is not as modular.
Yeah, I know the security model is different. I was just wondering, is that like the only thing that probably inspired it or not? I don't know.
Yeah.
Just to
Somebody
add
can
a
answer better.
small
Yeah.
comment to that as well. SDKs may be comparable, but the main thing is Substrate was meant to be used with Polkadot, which has shared security between all the parachains, which Cosmos does not have. You have, the little islands in Cosmos, but they have completely different security assumptions on every single one.
Hey, it's Shlok here. So my doubt is like, what makes ParityDB different than RocksDB? Like why was it designed to be like a parity?
Yeah. Again, not an expert at database, but what I understand is RocksDB was not optimized for blockchain type of data. We have very small blobs of data that we want to keep, and I think ParityDB wanted to optimize for the kind of data that we need for blockchains. Saying that, I think ParityDB is still like experimental, and there are issues with it. So I wouldn't completely say that we succeeded. It's still like a work in progress. I'm not even sure if it's been experimental for a few years now, so I'm not sure if it's still the recommended way. But yeah, I think the reason was to optimize for the type of data blockchains have. Okay. I'm going to move quickly to the next topic. Right. How many of you guys already know what is frame? One, two. Okay, few. Huh? Do you know? Okay. Good, decent, fair. Actually, I wanted to start not with the text, but more like a visual thing. So we said we want to have everything modular, right? And then when you think about the runtime itself has a lot of functional, probably separate piece of logic that can be its own thing, and that just needs to interact well with other things, right? So we've broken down the runtime to multiple palettes. We call this palettes, but these are like, you can think of it as, again, Lego pieces. And so, okay, let's say we have now these palettes. This is like finality thing, that there's some democracy, some balance, some way to stake your tokens. And these needs to interact well together, like play well together to be like a runtime, right? And all of these palettes need to do some things, like a way to interact with them, to send to basically they all are like a state transition function, right? You give it a transaction and it changes state. And so it needs to talk to the database. It needs to have a way to emit some errors, events, and stuff to the outside world. So you need some way for all these palettes to like play well with together. And so we need some kind of orchestrator. And then this executive and this system is, you can think of it as the orchestrating layer that enables all these palettes to work together. And so what is frame? Frame, now we go to the text. Frame is a Rust framework for more easily building Substrate runtimes. Basically, it's the framework that enables you to build these palettes, these functional independent piece of logic, and all the orchestrating layers that you need to make this happen. And to give a very objective example, so there's this palette, pseudo palette. You don't have to know about it much, but if you go to this palette and you can do a cargo expand on this palette, and you will see the whole code is around 3,268 lines of code to write this palette. That's a lot of lines. And with frame, which uses frame macros behind the scenes, it's just 318 lines of code. So you basically focus on the business logic, not the glue layers. Goals of frame, so make it easy and concise, flexible, modular. And so I told you already, I gave you a hint, and you probably already know that we use a lot of Rust macros behind the scenes, but the goal is for this palette code to feel as vanilla Rust as possible. We don't always do a good job at it, but I think that's where we want to be. Going through the building blocks of frame again, there is palettes. That's an independent piece of logic that has its own state. Macros, which wires everything up behind the scenes. The coordination layer is something, it's like a palette frame system, which is not like other palettes. It's like compulsory part of the runtime. You cannot remove that. There's executive. We will see that also. It's not really a palette, but it's like orchestration framework again. It makes sure how, in what order palettes work. Again, this will get clearer as we go. And then there's this construct runtime that you already may have encountered as well, which you give it a list of palettes and it creates a runtime for you. So let's go through palettes. What are palettes? Every palette has, not every palette, it's a choice again, but every palette can have a way to interact with it. So it supports an extrinsic that comes from outside the system to your palette. It has some storage, so it can be stateful. It can keep some things in memory. There are some things. So a good analogy is palettes are a lot like smart contracts, but there is some bonus that you get with palettes. They are extremely fast compared to smart contracts. And you get few things like some hooks inside a palette that runs every block. And if you think about what you can do with this, with a smart contract, you probably need some kind of trigger, some external trigger to do something. So let's say you stake something that needs to be unlocked in 14 days. After 14 days, it will not automatically unlock, but you will have to go and manually trigger unlock, right? It needs some external trigger. Palettes have hooks like block on initialization and on finalization, where you can do some things at every block without any user trigger, right? So some business logic that you can put that happens every block. So the way we interact with palette is through an extrinsic. Same, you can think of palette or runtime as just set of palettes. So with runtime, you interact with extrinsics. But how do you communicate to the outside world? Something happened, you use events. Something has happened, some state has changed, you emit an event. If an extrinsic is invalid, if it's trying to do something that your logic does not allow to do, you emit an error. It also allows you to have some logic where you can validate an extrinsic at the transaction pool level. So you can say if this transaction is valid, it should even stay in the pool or not. There's something called off-chain workers. Again, a lot of people confuse off-chain workers as something you can. So it's a non-consensus. It's like you do something, there's no consensus on it, and it's a parallel program that can run with your node. Any questions before I go further? Yeah, there's a question there.
I'm just like wondering regarding the coordinative palettes, because like the way I see it is that it's like you're giving me as a developer great strong weapons, and it's up to me to use it. So my question is like if there might be any overlapping between these kind of like palettes, how you are making sure that like this palette is not like overlapping with the other, like this kind of things.
I'm not sure if I totally got your question, but I guess your question is how we are making sure each palette is doing its own, like not redundant things, right?
Will I intentionally or easily enough be able to overwrite storage values from another palette?
Yeah,
Again, intentionally or at least
yeah. So
It could be intentionally or because like I'm a developer and I'm a human being and I do mistakes.
yeah, so we will actually build palettes, and you will see this in practice, but it's not easy. It's possible. Technically, it's possible. Everything is just storage and some way to create that key in that database. And if you work with the frame, at the frame level, you don't even care about all these things. We will go into the internals, but you don't care. You just think that the storage only belongs with this palette, right? And unless you use like very primitive levels of APIs, where you create your own key, you try to hash and stuff, you cannot access other palette storage. But if you want to, you can use very low-level APIs and actually change values of other palettes. It's possible, but I don't think it can ever happen intentionally. Yeah, go on.
Can I add something?
Yeah.
I feel like that's a great point in time to mention one of the other key differences to smart contracts, which is that the different palettes are all part of your runtime and you're in a trusted context. The transactions that come in, they're not trusted, but the code that you put in your runtime is assumed to be trusted. So the framework helps you avoid accidental collisions that you didn't mean to have, but in the end, you're responsible and also empowered to make sure and responsible that it doesn't collide because you have control over the code.
Also, while you can use low-level code, like he mentioned, to like manually choose the bytes, the key that you want to overwrite, you can, so as Alex said, palettes are all part of your runtime. So you're developing the runtime. You use palettes as a way to modularize it and like write better code. But you can have one palette expose an API, and we have very like easy ways of doing that, not like low level, but like expected. And then you can, from another palette, use all the functionalities from that palette, which are not only limited to changing its storage, which is the storage of your runtime, which is like namespace it to each palette, but it's all your runtime. You can also like make an API call that does something and then changes storage. You can even have one palette be like a callback for another palette. You can communicate between them effectively. We have very easy ways to do that.
Hey, Marcin here. I have a question. Is it safe to emit event in a palette, like before running the logic, or it can be exploited like in smart contracts?
Yeah. So the way any extrinsic, any call logic works in the palette, if you at any point error, everything is reverted. Even the events will not actually work. So ideally, you want to do as less compute as possible before breaking. So you do all the sanity checks and then do state changes. But technically, you emit some event, you do some storage changes, and you later realize, this is not good. It's getting us into a bad state. You error, and everything else gets reverted, right? I'm not sure exactly what is the smart contract event exploitation, so I don't know if that answers your question. But.
So I've read there is a thing in Ethereum smart contracts where you emit event. There you can write a script like you catch this event and you can rerun the same smart contract. So it's like basically constantly going at the beginning, but never is going at the end. So you can like rerun it multiple times when you just catch the event.
Yeah, I mean, if you write it correctly, I mean, also it's kind of very custom, right? So you can write your own logic. If you are doing something and not erroring out and just emitting event, then you can. So it's more to you, like the code that you write. There's no inherent exploitation that you can have, but if you write a code in such a way that is dosable, then yeah, it's a problem. But we can talk about this more or look at exact scenario once we start writing some code. So maybe you can try to tell me like what exactly situation you have in mind. Oh, just
Hi, it's Roger. I was curious about, in the slide when you show the node and the runtime, it makes it look like it's completely separate, but it's really the same code base, right? And I was wondering on the forklift upgrade, does that apply only to the runtime, or could that also apply to the node?
yeah. So, I mean, it's a monolithic code base, but it's not exactly same. So this runtime is just a Wasm blob in your chain state. Okay, you can run something called an Omni node, which supports multiple chains, and you can just build your runtime blob and upload this, and it will work. So runtime is actually very separate. It's like an embedded thing. It's like JVM, right? And you run a Java program inside it. So JVM is like a host, which is kind of similar to what our host is doing, the node is doing. What was the second question?
The forklift upgrade.
Yeah. Nodes cannot, I mean, so what is node? Node is some software that everybody is running, right? And if something changes on the node level, then everybody has to update. There's no way to automatically update it. But most updates, so what we believe is generally the host and runtime interface is very stable. They rarely change. You have a new crypto primitive or you have something like, yeah, very rarely it changes. And so most times you will never have a node update that you need to do. It's generally the business logic that changes, right? And so almost always it's a forklift upgrade, but when your host runtime API breaks, then you have to do a node upgrade. Or some vulnerability in other parts of the node that, I don't know if it's the networking layer. That's it. That's
Please wait.
Is it possible to have re-entrance attack on frame palette?
So correct me if I'm wrong, read is you execute the same transaction again. You execute the same transaction again, right?
Yeah. Is it safe?
Re-entering the same function again is what I'm hearing from over there.
Could you explain a bit further? Like, what is it?
So basically how it works in smart contract in Ethereum is like I'm calling a function X and then internally doing kind of like external call to another contract, and this contract re-enter the same function with the same state. So like we keep like in the loop until we exit. Keep calling the same function while we are keeping the same state for the same transaction, I mean.
Yeah, I mean,
in Solidity context, this is a re-entry attack, where is this function that moves some balance from one address to another, and then you can use some loophole and call it multiple times while it's intended to be called once. And the difference here is this is a function within the execution context of the smart contract, within the Solidity virtual machine, as opposed here to pallet execution context, which is inside your runtime. And this function has almost all the code here is exclusively written by pallet developers. It's only calling the pallets that are part of your runtime.
Yeah.
Does that?
Yeah, so to paraphrase, all this code is a trusted context, right? You manage all the runtime pallets. It's not like a open environment where, like a smart contract, you can just upload any pallet. You cannot do that, right? So again, you control all the pallets. You can only do this intentionally, this re-entrancy, if I understand correctly. But I think Cisco wants to make a point.
A lot of exercise actually.
Thanks. So I see a lot of comparisons between smart contracts and pallet development, which is understandable. But again, I mean, we've said this a bunch of times, but all pallets are part of your runtime and you control what you are building. and every time there's an error, everything rolls back, and at the end of the day, it's all part of the same program. So there's no such thing as like, oh, maybe this palette will not roll back the color palette. Palettes are not like sandboxed environment and untrusted code as smart contracts. So at the end of the day, once you have a runtime, it's one thing, and everything acts as one thing. And if there's an error anywhere down the line, even if you re-enter a function or whatever, everything will be rolled back, and you don't need to worry about it. And everything will be benchmarked by the developer as well. So there's no issues with gas either, which is a very big change that we will talk about later. But there's also no issues with gas in this case.
I'd like to add though a couple of things. So there are, if you intentionally write a code that is like an infinite loop, what will happen? Sorry? Yeah, it might crash your VM if it runs out of memory, or it will just stall. Your chain will stall. It will just keep going for a long time, right? It's fine.
Yes. Okay. So to repeat what you said, please like raise your hands so I can come to you to raise the microphone. Also, I think I'm gonna jump in here and say, like, yes, this is a little bit of a conversation in that we want you to learn, and we're really happy that you're engaged. But also, I think we should like run the presentation and you know get to the content.
Most of these things will be way more clearer once we learn how to build with palettes, and we can revisit all these questions again at some point. Okay. Let's look at quickly the structure of a palette. So you have some struct palette that you define, and you give it some macros. You say this is a palette, and what does a palette have? It has something called config, which you can think of it as a dependency injection thing. You can inject few values, few traits that are implemented by something else. There is, there's call. So this palette call, this impl of palette, so a struct, the impl of struct palette, you can have functions which acts like extrinsic to your palette. The way you communicate is if there's an error, you emit an error, your call fails, your storage change is reverted. Or if the state change is successful, you can emit events, one, multiple, your choice. And then there's frame macros, which does all these binding things behind you, so you have to write less code. I think Cisco will later in the day also show you how these frame macros work, at least parts of it. And this is something that you can try to do yourself. You can go and do cargo expand on some code, and you can see how much lines it is once expanded, and without expansion, how much is. So it's with, I think, the pseudo palette, right? So it's the thing that I shared before, 318 lines without expand, and 3,268 lines when you expand the code. Yeah.
If you can go back to the slide where you are showing the palette structure, I'm just wondering what's the difference between like when we define the palette, the pub struct palette, and the storage, because like the first moment I saw it, I thought like this is where I'm defining all my storage variable. If there's any difference, I'm assuming this might be for like all the variables, and the palette storage is where I actually like saving to the database. Like if you can give more explanation or elaboration here.
Are you talking only about specific macro, or?
You have in the macro, which is palette, and then you have a struct palette, and then in the bottom you have the palette storage, and you have a comment where we are defining something I don't know. So I just like confused.
Yeah.
I'm sorry, I'm coming from a smart contract background, so for me.
So I mean, again, we can go to the actual code to look at this and understand this better. But just So you understand here, what I mean by palette storage is you can define some storages and you can all like put this macro on the top and it will just work. So let's wait. Let's go to when we actually start looking at the palette code, and this hopefully will get more clearer.
Okay. So the struct palette does not have anything to do with storage. Is the sort of the short answer, and then the rest what he said.
Right. And there is this, I already hinted on it, there is a palette called frame system, which is a compulsory palette that you need to always have in your runtime. And this is kind of used for more meta things, like how does your runtime orchestrate all these palettes. So yeah, something to remember. It doesn't, yeah, it's almost like a normal palette, but yeah, when we will look at the other palettes, you will see that every palette extends from this frame system config. Okay, yeah. So what does frame system do? It keeps track of block numbers, accounts, what hash you're using, stuff like this, which is not exactly a business logic, but again, used for general orchestration of the whole runtime. And then there's frame executive, which is not a palette, but still it's one of the most important module. It has these things like how to execute a block, when the hooks are called, when does your chain migrate, how do you validate a transaction in your transaction pool. So all these things are in the executive. Again, I don't want you to like understand all this, but I'm just giving you some terms that you can remember later. We will go through almost everything that I'm talking here. Then there's construct runtime, which basically you say, these are the palettes that I want in my runtime, and it creates some kind of code for you that looks like one single runtime, right? Yeah. So, I told you about frame config already. It's like dependency injection in a way. So, what's this? So when you write your palette, you say what you need for this palette to work correctly. Some types, there's no trait here, there's a trait here, there's a trait here, and you want the runtime to inject this type or trait implementation from the runtime there, right? And then in the runtime, you say, okay, moment is U64. The on timestamp set, that trait is implemented by Aura. So you're basically loosely coupling two palettes, right? So Aura is also a palette. Similarly with others, right? So you have don't have to care about too much about weight info, but it's also going to be significant when you start learning more. Yeah, that's a short intro to frame. I still can take 5 more minutes if you have questions. And you don't have to think again too deeply. We will go into detail for everything, but high level, do you have like doubts about why there is frame? Why do we even need frame?
I think we were talking about like palettes accessing each other and maybe like errors. Is atomicity something we have to implement when we design a palette?
Yeah. Say it again. Sorry.
I guess when extrinsics interact with a palette, there can be like issues with storage, and we might have to roll it back if maybe there's at some point an error. Is atomicity something we have to design when we?
You don't have to worry about it. So we'll go again to the call, but in a call function, at the end, either you will return an error or okay, right? If you return okay, everything, all the state transition things that you did gets finalized. But if you return error, everything gets reverted. You don't have to think anything else other than that.
With the small asterisks that, of course, you need to care about the interactions between the palettes. If you make it complicated enough, you might succeed and then make changes that you didn't expect, like, complexity of your code. But
yeah, but if you do okay, then yeah, everything that you do will go on, right? So you have to make sure that if you did okay, it is okay.
So for example, there are cases where we say everything is okay, but there actually was an error. And so stuff is like committed to database, but we said but it actually was an error. Like when you, for example, have a call that is wrapping another call and the inner call succeeds, but the inner call fails, but the outer call is like, yeah, I successfully dispatched your call. It successfully failed. So yeah, it depends on you. But the idea is that if a call returns error, everything will get rolled back. Of course, if you like take a call inside your call, and if it fails, you catch it in a way, and so it doesn't need to roll back, then of course it's up to your code. But we have examples of this, and we allow you to do whatever you want with it. So if you say it's okay, make sure it's okay.
And I mean, so another thing I think somebody asked before, how do we test? And there is another very useful piece of testing primitive that we have. There's something called like tri-state checks, where like off-chain, you can have some invariance tests. Like when this state is this, then this should be true, right? Things like that. So you can do all these, you can write all this kind of logics where you test some invariance and make sure that your chain is actually working the way it is working. Also, yeah, and it's like a later feedback. You will know only once you make something wrong, but you can run this as a part of your unit test as well. So you can make sure your invariance always is correct. Okay, I feel like I can do with 5-minute break. So
there was one.
Yeah, if you want to grab a call. Oh, there's a question. Sorry. Yeah.
Just a curious question. I'm wondering if the optimization in the palette itself would affect the transaction cost for the end user, or the computational requirement that the node needs to have?
I mean, both. So there is a lot of optimization we already make, but as a runtime developer, if you're writing palette, you need to understand what is the cost of what you're doing, right? So you need to, there are a lot of optimizations you can do by yourself. If you understand, the internals, the primitives that you're using,
Will we have like a lecture about like how we can optimize this safely?
Yes.
Okay.
Yeah, so Alex will actually, so one important thing that I think is not covered here is that unlike smart contracts where you have gas metering, here you predetermine the weights of your calls, of your extrinsics. So you kind of calculate the worst case weight, some dynamic calculation of the weight that your extrinsic will take, and you calculate this, you create some kind of weights. We call it benchmarking your palettes. And I think Alex will actually take you through a whole exercise where you can learn more about this. Okay, let's get started. So this lecture, we are going to dive into the calls. This is your entry point into palettes. So what are calls? Call allows user to interact with your state transition function. So we'll go through like how you can write your own call logic. And there's some confusion sometimes. We refer to the call in a few different ways. And so just so you remember this, if we call it a call, extrinsic, or dispatchable, almost all these terms are same. We mean the same thing. And this will get actually more clearer in the frameless exercise that we'll do in the evening. But the way to think about it is extrinsic is something that is coming from external source, right? So extrinsic, user submits an extrinsic. Now the runtime dispatches, it figures out which palette this call belongs to. It dispatches to that palette, right? And in the palette, we have a call function that is executed. So all three terms are same. How does your call function look? So I told you that we always have to calculate the weight beforehand, before the execution. So you do a impl on the pallet struct, you give it some weight. This weight info is your worst case weight. Then you also give something called call index. And this again, you will learn more as you understand how this runtime amalgamation is happening. But beneath, like to give you a little bit of a mental model, the frame generates a big enum of all the calls, all the errors. And so for enum, if let's say you move your function, move the function order, you can break some APIs, which is why this call index is very important that you put it. So the order does not matter, right? So whatever index you say, the next time, like if you try to put the same index for a new function, it will actually, the compiler will actually give you a warning. You define a function, just a normal Rust function. Important thing to note is every call must have this origin for parameter. You can think for now origin as an account ID, but that's a very understatement, because origin is very much programmable. As in, it's not really account. It can mean a lot of other things, and that you will learn later. But for now, you can maybe have a mental model that origin is an account. Some other parameter, it can take any parameter as long as it's bounded. So there is some boundedness that we need every call to follow. As in, any Polkadot block has to be actually now it's 10 megabyte. So your call parameters also cannot exceed that size, right? But there's otherwise no limit what you can put as parameters as long as it implements few traits. Yeah, sorry. Alex, sorry, there's a question there.
Thanks. Does the call index, and you said the importance of its order, does that relate further down the line somehow to make, is it passed to scale, and we know that scale requires ordering that can't be changed? Is it because it's not, well, is it because of that, or has scale got nothing to do with it?
I mean, it is about scale. So scale does like serialize your enum in some order, right? And so if you change the order of the function, by default, if you didn't have call index, it would reorder in a different way, right? And that will break some metadata, right? But with the index, it doesn't care about the order. It cares about the index. Cool. Every call also returns something called dispatch result. This can be okay or some error, right? If you say okay, it's the state transition function succeeds. If you say error, no state is changed and everything is reverted, rollback. And there's another type of result, dispatch result with post info, where you can update the weight. So you start off with like worst case weight, but if you realize that there's like less computation that you did, you can charge less weight. Yeah, question, sorry.
Hey, Marcin here. I have a question. Did the call index need to be like always by one higher, or it can like skip some numbers and it's okay?
It can skip.
So we can like every 10 even use or whatever.
Yeah, if you want.
Matter.
I mean, it's weird to do that, but I mean, yeah, you can do it. So the way this works here, the way we also put indexes for the palettes and runtime. And you will see that we do this a lot, where we try to put the similar palettes together and we give some numbers free for later if there is a new palette that we introduce and we want to keep all of them together. Yeah. but it also allows you to actually put things in code together, but the index can be different. So it's up to you. You can use it the way you want. The only limit is it's U8, it's 1 byte, so it's like 255 is the maximum number of nested values you can have. And the first line, actually, this is a very common line that you will see in almost every call. You ensure that the caller is a signed account, right? And you get the account ID. Again, origin, very programmable, but for now, I'm simplifying it as account ID. You will learn more. But in this case, we just get somehow the signed account ID, and we do something based on it. We look up the storage, do something, and if everything goes well, we return OK. We return OK, the state is committed. You could have emitted an event here, all OK. And let's say if you did some check, right? So here, you're doing this ensure sign check, you're doing this some lookup thing, and if one of these errors out, it will actually return an error. And all the, let's imagine you try to do this mutate beforehand, and you return the error later, everything will be rolled back. Okay. So I already explained this. So you just make an impl of the struct palette, and you put this macro on the top of it, and then magically all those functions inside that becomes extrinsics. Origin, very important. So every call must have this origin parameter. It's coming from the frame system. So this thing called runtime origin is what is coming from the actually the whole the you will learn again more. I don't want to go too much ahead of myself, but runtime origin is like an outer enum that is on the runtime level, and this is every call must have this parameter. So what are these origin? The basic origin types are 3. You can have something called root, which kind of a root level access. You can do things that you should generally not be allowed to do. You can have a signed transaction where there's a user who has signed with their private key. You get the account ID, you do something with it. You can have a non-signed extrinsic, which sounds weird, but you will again learn something called inherent. You can have a unsigned transactions. And you can also actually make your custom origins, and we'll go deeper in another lecture about it. Yeah, kind of covered all this already, but I'm going to pause all these slides. So if you guys have any questions, you have a question.
If you can go back to the slide where we have the balance function transaction, yeah, right? Yes, it's cool. I'm wondering if this is a dispatchable function where the end user can call directly. Is it correct?
Yeah.
Okay. Is there any difference between the dispatchable function that the user can call and other type of function which only callable by the same palette? And can I do inter calls between function which is dispatchable or not? And because you mentioned now the origin, like in this inter call, let's assume we have 5 calls internally calling each other. How the origin would be different, because I'm seeing it from Solidity. So I see it like the origin, like in the origin in the transaction sender, stuff like this.
So
Thank you.
first mental model to think about is this is much lower level, not a sandbox environment, so everything is controlled by you. The second thing is this is just a normal function. Okay, the only magical normal Rust function. So inside your module, you have multiple functions you can call each other. It's all fine, right? What you're asking is from this call, so basically this palette call macro and this palette call index is what makes it magical, right? It makes it extrinsic. And what you're asking is if you call another call with this, and that's kind of called redispatching. Generally, you don't do it, but sometimes you do it, and we will show examples of where you do it. But generally, you will call, let's say you have a same palette and you have two calls which kind of does the same common thing, right? You will have an internal function that is not extrinsic, and you can call from both of them that function, right? So yes, you can call your internal function just a normal Rust program, and yeah, does that make sense? Yeah.
So actually, you can see it in the example. If you look at self as fungible mutate transfer, ignore the as fungible mutate, that's just a trait constraint, right? But it means that there is an implementation of a function called transfer, which does not take an origin, but instead takes a source. And that's a plain old Rust function that will be defined somewhere else in the palette, somewhere else.
In this case, like it's impossible to be called from outside because it's kind of like internally called by the module itself or the palette itself.
Yes.
Gotcha. Thank you.
And we use the Rust kind of visibility system, module system, in order to control visibility between different palettes. Because in some sense, a palette is just a crate, a Rust crate, right? So we reuse the Rust visibility.
I said almost everything can be a parameter. So the only restriction for anything that you want to put as a call parameter is it should implement these things. Codec, encode, like it's basically scale. It should support scale encoding, clue, equal, debug stuff. So yeah, if your parameter implements this, you can use it as a call parameter.
My question is, what are the weights and how are they calculated?
Very deep topic. For now, you can just think you're trying to predetermine how much will be the computation of your call. And you can dynamically also figure out or calculate. So you can have like dynamic function which calculates this values. But again, Alex will go deeper, way deeper into this than I can explain right now. I told you there's a parameter limit. There's not really a parameter limit. There's a block size limit. A lot of people, I guess, are coming from smart contract background and gas metering, and that's like computation cost. In Polkadot, we have we call it weight, which is two-dimensional. So you have computation cost and some storage cost. And the storage cost, we have this limitation that every block must be maximum of, I think this is now 10 megabyte. I have to confirm this. It used to be 5 megabyte. And so naturally, your call is also has to follow this limit. Otherwise, yeah, we cannot do a bounded execution. This probably you have learned in scale. You had the scale session, right? Yeah. So you can also have compact parameters, which basically reduces your size of the parameter for almost every possible value. So yeah, just to give a recap, let's say your balance is U64, but most times the balance is very small, right? 1, 10, 100, 200. And then you can store it in a much smaller bytes than using the full bytes. And that's what basically is compact encoding. Yeah, to back up what I was saying, it's just plain Rust logic. There's nothing special going on, except when you put those macros, and that magically becomes extrinsic. But everything that you can do in a Rust program, you can do it here. Actually, I'd like to point out, which is not mentioned in this slides, and I think a lot of people struggle with it. We do run in a no STD environment. Because we are running inside a Wasm execution environment and we want everything to be deterministic, and a lot of IO operations, the STD Rust supports are non-deterministic. There are like float operations also that it does, and those are non-deterministic. And that's why we re-export few things that we need from the STD libraries, but your palette code is in no STD environment. And it's important if you start trying to use something that is coming from STD library, then your palette will not compile, or your runtime will actually give weird errors. Okay. Important thing to point out, your call should never panic at any time. Can you think of why? Anybody wanna take a guess? What will happen if your call panics? Every time that extrinsic is trying to re-execute, your VM crashes, you basically can stall your chain unless you remove that extrinsic from the pool and somehow restart all the nodes and stuff, right? Yeah.
What happens if you call panic, right? That's the question. What happens if panic is called?
Yeah.
Transaction fails.
It
right?
doesn't just fail. Every time you try to execute that extrinsic, first of all, you do some computation, but it is never able to finish that extrinsic execution, which means you are doing some computation that fees is never charged for it. Sean, you
Yeah,
want to
I
add
was going to
something?
say exactly that. So I think that we made a decision. So you have to think about this. Whenever you execute code, you have to open up, we have to like from the client, open up a WASM executor and execute some code. In order to like minimize the cost of the stuff, we do the fee calculation in the same WASM instance as where we do your function call. So this means that if your call panics, the fees will also be taken away. So it means your computer or your node did a bunch of work, did a bunch of computation, and then the thing panicked, and then the whole thing basically didn't take any fees. This could be solved. Like you could create a system where you could allow panics by basically separating the fees from the call execution, but then you have to spin up two WASM instances, and that's very expensive, right? So the idea here is that you as a runtime developer, we can make your code or make the blockchain much more efficient, and we just ask you, do not write code which sucks, right? But yeah, we don't allow panics because it allows a user to arbitrarily DOS your blockchain without taking fees.
This question here.
Slightly thinking out loud, so forgive me for that. But would it work where the fees were calculated in a separate thread that was then joined?
Yeah. So I feel again this is going into details which we have not even explained, and it's hard to explain this properly.
Yeah,
there is a frameless exercise in the evening, and actually I will try to dive deep into this. So ask me then, okay? And I would like to make that clear why the fees will be charged and the extrinsic never executes, and you are doing computation for which you are not charging, right? Yeah.
I guess if there's a panic, then the dispatch result is never actually called. So is there like a defer for like an error by default, or how do we roll back when there's a panic?
Yeah, I mean, so everything happens so every extrinsic starts executing in like a sandbox, in like a overlay. And that's why we can roll back easily, right? So when it panics, the changes are never flushed. Sorry, say again your question.
I thought I understood like before when I asked about like how atomicity was done. Like if we return an error, then we revert it. Otherwise, we don't.
Yep.
And I guess in a panic, we wouldn't be able to return it.
Exactly. So when you panic, basically this overlay changes are never flushed to the database. So there's nothing to actually revert. So this actually will get clearer in tomorrow lecture. We go through how storage is managed, and you will see how this works, and probably this will be very clear. Okay, I'm gonna move on because I feel like running out of time. So you cannot panic, but what you can do, return an error through this dispatch result. This is what I hinted on. There is like this transactional storage layer. So every extrinsic starts in a transactional overlay where you do something, and once you are done with it, you flush the changes to the database. And if that panics and that that thread gets lost, then nothing is committed to the database. Yeah, they talked about it. Call index. Yeah. So the way your call is encoded, I hinted there is this outer enum where there is a set of pallets, and nested inside it are calls. So any call, when you try to see the encoded value, it is 2 bytes. First is the pallet index that you define at the construct runtime level, and then the call index that you determine at the pallet level. Everything should have a weight. Yeah. One thing I do want to cover, all these things maybe seems complicated, and maybe when you want to start, you don't want to care about weights and stuff. What you can do, just to start off, not at the end. So we will have an assignment in the evening that we'll give you. And it's okay to start off like this, but in the actual, when we grade it, we would not want you to do this. But just so you know, there is something called dev mode macro that you can use, which will mean you don't have to put call index, you don't have to put weights. By default, it just puts it as 0 and call index as whatever in the order. And this is only while you're developing. If it is in production, you should never, ever use this. These are the things that basically dev mode does it for you. No weights, no call indices. Storage can be unbounded, and you don't need a hasher that I probably didn't show you. I'll cover this in the storage, but when you create storage items, you tell how you want to hash the key. And yeah, you don't need to do that in dev mode. Yeah, question at the back.
I have 2 questions. The first one is related to the the dev mode. Is there any way to do it from the CLI? Because for me as a developer, I might forget. Like changing the code is not the best for me. I want to kind of switch between the dev and the production mode.
Yeah, so I am not 100% sure on this. You have to try it and check it, and I can try and check it. But I think your compiler should give an error if you try to build a release build. If you do a normal cargo build, it should be fine. When you do
But I have to put it in the source code itself. There is no way to do it from the CLI.
No. But this is only to start off. You should never have in your code that is runtime
Generally, when we develop, we start compiling in the dev mode because it's going faster. And then when we want to test our code or want to go to production, we compile in the production mode.
I mean, so this dev mode it's just like a starter thing where you don't have to think about complexity, but don't think of it as a compile thing. So you still are compiling your release or debug builds, right? The debug builds are faster and everything. That's all good. But this dev mode is only for you to get started as a pallet developer.
It's not a question. It's a confusion I have, and I want to make sure I get it correctly. If you go to the slide 10, you mentioned here the max size should be the maximum is 5 megabytes. And as far as I remember yesterday, mentioned it was 10 megabytes for the parachain transaction. Is it different? Or
so this used to be 5 megabyte, and I think now it's 10 megabytes. Okay. So I think the other lecture was correct, and this should be correct.
Hi, Marcin here. I have a question. Is there a good way or good practices to estimate the weight of a call?
Yes, there are again, the benchmarking exercise will go in deep into all this. Benchmark is pretty important because it can allow you to DDoS the chain, right? So yeah, we will go deep into this.
I promise.
Okay, the last thing that I've.
Do we have time for one more question? There's
Oh
one
yeah,
more question.
sure. While I set it up.
Hi, Juan here. Checking the calling coding, it says you have 2 bytes for.
Sorry, where are you? I can't see.
Here.
Okay.
2 bytes for the palette index and 2 bytes for the call index. I think that limits the number of calls from a palette to 256. Is it? Don't you think it's a bit tight?
So
quite borderline, I would say.
Yeah, so 1 byte for
1 byte each. Yeah.
1 byte each index, one for palette index. That's 255 multiplied by 255, right? So yeah, your palette has that limit. I don't know if there's a way to increase that limit, but I think it is not. We have not hit that limit. If your palette is doing 255 function, probably you should break it up.
Yeah, that's what I thought. But
yeah,
I think there are, like we were talking about that beasts like Polymarket can beat that easily. Don't you think? Can
In terms of
surpass that.
extrinsics and like callable function, like from the outside, because we're not talking amount of functions in the thing, right? We're calling.
Yeah, I mean talking about the number of functions that a palette can have.
Okay. All right.
So maybe there are palettes that need more than 256 calls.
Historically, there's not, and like you can have 256 palettes on your runtime, and you can have 256 extrinsics on each palette. So you can have 65,000 calls if you want to. So if for some reason you need like so many entry points because you have so many different stakeholders and apps and so on, instead of just like unifying them into one thing, or maybe you have a lot of like technical debt and you need those things for backwards compatibility, you have a lot of leeway. You just need to create new palettes. Maybe you move everything into new palettes. Like you have a lot of things you can do, and I don't think anyone has ever reached that limit. That said, this is all a frame thing, not a substrate thing. So if you need a bigger limit, you can always drop down from the ladder of abstraction from frame to substrate and just create your own tweaked version of frame that allows like 2 bytes for calls, and then you're like good, set for life.
Perfect. Thank you so much.
Okay, shall we move on? I have like 14 minutes, but I'll try not to rush too much. So I told you this extrinsic that we have, it tells you an error, but it never like gives you back any output, right? And how does basically a user understands what's going on with the chain? There are 2 ways. Again, error with the dispatchable, but the other way is event. So whenever some state transition happens, you can emit an event that you think is useful. And yeah. Let's go. We already seen the errors. There could be a lot of kind of errors you can have. Yeah. Yeah, just a lot of detail, but like depends on your business logic. What you're doing, maybe that resource some user cannot access, stuff like that, and what you can do is just error out as quickly as possible. Yeah, repeat of we have already covered. So like the way I said, the call is like this amalgamation of runtime indexes and call indexes. There's also a runtime level dispatch error, which is basically these enum variants that we have. And if you look at so almost all of these errors except the module are like high level errors. So I'll go this more in the frameless exercise, but when extrinsic enters your runtime, you can think of it in, there are 2 phases of execution. There's a pre-dispatch phase where you do some kind of validation, like nonce is valid, transaction is valid. the encodings are correct, it actually dispatches to some palette. Stuff like that. You can add multiple checks, and this is the pre-dispatch phase, and all the errors that you see can be in as part of the pre-dispatch phase. And then there is this module error, as you can maybe imagine already, belongs to the palette itself. So on the palette level, you can define your own errors, and so the palette error will be encoded as dispatch error, module, and some module error, which is your palette error. So going back, what is module error? It has 3 fields: index, your palette index, error. This can be 4 bytes, and some message that is not encoded. So this is only something that you emit, but yeah. The error is 4 bytes, right? And let's see an example. So how do you define an error? You have some palette. You put this macro palette error, you define some errors. Again, normal enum with some macro that turns it into a dispatch error. And in your call, you're doing some checks, and if some checks don't are not valid, you return an error. So in this case, we are if the signed account is not the owner, we return a no owner error, or not authorized if based on your logic. And it's not just about communicating to the user who's doing this extrinsic. In your tests also, when you do your assignment, we'd expect you to test for different errors. Don't put like random errors. The errors has to be meaningful. It should convey a message, what went wrong, and kind of convey what actions you need to take to fix it, right? Yeah, and if you try to actually look at the encoded palette error, so if you just encode this palette errors, basically it's like a normal, that scale encoding. So first variant is 0, second variant is 1, right? But when you try to encode it into a dispatch error, you are doing this no inner converting into dispatch error, you will see it is encoded as something like this. And so this 4 bytes is your palette error. This 1 byte is your the dispatch error, the 4th variant module error, right? This is your palette index, and this is your basically palette error. And some of them are unused. So if you have so in this case, we have this simple enum, right? Technically, you can have a nested enum up to 4 bytes, or have some values here which can be such that the whole thing is just 4 bytes. So some can be unused, but in our case, it was here on the top 3, 1, 1, right? And the 3 are unused. So the first value 3 comes from dispatch error variant module. The second is the palette index. The third is your error. We could technically use the other 3 bytes as well if you want. Yeah, an example of how you can utilize all 4 bytes if you want to. You can have nested errors. And then it takes 2 bytes here. Yeah. And the data error takes 2 bytes in itself. So that's 3 bytes in total. Okay, what are events then?
You have a question?
Yeah.
About the errors, presumably.
I have two questions. The first one is slide 10. The encoded errors. Is it best practice like to return encoded errors, or we shouldn't do it? And if we are encoding, are we adding more computational power, like resources usage?
I didn't catch the word. What is it?
Like the slide 10 where we are encoding. So we're returning encoded error message instead of like returning the string itself, returning a value like which is 0, 1, 2, whatever. So my question is it best practice to return the error encoded or like normal errors?
You don't need to encode or decode by yourself.
Yeah,
generally.
it's best practice or not?
No. You don't have to. It's not even, you don't have to at all. Like we will go through the code and you'll see this, but you never have to. In almost every case, you don't have
I
to.
know
use
that
it.
as a palette developer, I can do whatever I want. I'm just like, yeah, like I can do like any bad thing, but
Yeah.
is it good to do it or not?
So you could encode it and keep it encoded, and then the system can double encode it, right? So, I mean, you can do it for sure, but generally you don't need to. And again, you'll see the code, but yeah.
In slide 6, when you are doing the pre-check thing, I'm just like, it's a confusion area here for me, because like I think day 3 or 4, we were discussing about like checking the transaction in the mempool before executing it in the runtime. Is this a part where we are doing this, or I'm mixing stuff?
Do you mean the transaction pool?
Like, yeah, like when we are kind of doing pre-check before or even like it's valid, but we didn't run it.
Yeah, so simplified way to think about it is, you can think of your extrinsic is in pre-dispatch phase or a dispatch phase, right? In pre-dispatch phase, we do multiple things. We can do non-checks, we can do transaction checks, we can check that the user account has some balance before even going and dispatching to a pallet, right? So pre-dispatch phase, you can do all other errors. I mean, even from and the second is dispatch phase, where you can go and define your own pallet errors. But even in the dispatch phase, if you want, you can use these, but you don't have to.
So just like to make sure I got it correctly, this kind of pre-checking is like in the mempool phase where we are pre-checking the transaction. Okay.
Yes, so in pre-dispatch phase, you can look at the extrinsic and you can do some validations on it.
This module error is past that. So like, there's no amount, like we can do all this cheap pre-checking, but we can never know whether or not the function will execute successfully. This error is after running the code, if it will succeed. Like there's only one way to know. We have to run the code. The user will pay a fee no matter what. The error will be in the block. Like there'll be a transaction that returns an error. We can't remove that from the pool, like or whatever. So this is already after it's past the pool. It is a valid extrinsic. The valid extrinsic results in an error.
We will have like lecture where we know how we are doing the pre-check in the mempool things, like in the node.
You shouldn't. Yeah. I mean.
Yes, I will have a lecture on this.
Sorry, Tom. Okay.
But I will also kind of show you in the evening exercise how this has happened on a bit naive level, but also we will walk through some code that happens in Substrate maybe tomorrow. Okay, move on to events. So your basically extrinsic is a way to do some state transition, right? And maybe some important events happen and you want to convey this to the outer world, and you use events to do this. So again, event is also this outer enum nested with the inner palette values. You define it in config, and every event that you define in a palette must convert back to the runtime event. This is generally confusing, but I think it gets clearer once we start looking at the outer enum and inner enum kind of thing that I think Cisco will cover. Yes. So this is how you define event. And if you see this generate deposit something, it's creating this fun deposit event. So what it does is it creates it makes it easy for you to deposit an event. You don't have to worry about how it's working under the hood, but all you have to do is this in your palette. Self-deposit event, some event enum that you created. That's it, and it will take care of everything, right? And if you look at what this deposit event does, it basically is a macro that does this code. Yeah.
If you can go back to the previous slide, like the just highlight the report. So here we are like explicitly saying this event is only for this function. And what if we want to have events which could be triggered or emitted in? Okay.
So you are just defining an enum of events here, and then you decide in calls, the call logic that you write, which event you want to. Yeah.
Hi, Juan here. I had a question since the very beginning when I started to code in Rust, well, in Train, and it is, what's the possible outcome of not handling properly the events?
I mean, it's your business logic, and there are tabs, there are users interacting with it, right? And so how they figure out what has changed in your system. Either they look for all the storage changes, but storage changes are a little bit like, it should be like a black box. You should generally not care about it, and it can change and can break, right? Event is a way to, like your apps can subscribe to events and look for events that they care about and know something has happened. So you are staking, stake confirmed, something happened, it's good, your dApp reacts to it in some ways. Yeah. Machi, you wanna say something? Okay. So internally, whenever you generate an event, whenever you do this deposit event, it's actually stored in database. In this frame system, there is a storage. By the way, this is the way the storage value is defined. We'll look again later deeply, but you're saying there is a storage value, no keys, just a value, which is a vec of like events. And you might already guess that this is unbounded. We keep it in box because it's unbounded. And the thing is, we said that anything that we do in blockchain needs to be bounded, right? And this is an unbounded storage value, which means you should never read it. The only thing that we do is append to it, and that's it. Yeah, there is this another thing that I think is not used in palettes, but probably is supposed to be used with smart contracts, where you can even put like some topics that any event belongs to, and your dApp can actually subscribe to some topics and only listen to those events. There is one very interesting detail that you should remember when you're testing your palette code. At block number 0, we don't emit any events. So if you're trying to do something in your test where you do something and you hope that there's an event that is emitted and you are not seeing any events, it's probably because you need to increment your block number. Do you have any guess like why we don't emit any events on block number 0? Yeah. Sorry, Alex.
Because it's our origin, and it should be like implemented externally, like we start from there.
I mean, not exactly, but sure. So I mean, you always have block hooks as well, and you can generate even there. So that's not exactly the reason. The reason is basically when you create your blockchain, you give it a genesis state, and every palette can have like big genesis state. And if we start emitting events, it will be crazy number of events at the genesis block. So we just avoid generating events at the block number 0. But yeah, after block 0, genesis is gone, and then we emit events.
Could it also be because like at the Genesis block, if you have multiple people trying to issue it, like you can, well, I know it's 4+, but like you can create multiple states. So instead of saying, well, this is the Genesis point that everyone starts moving forward from, there's no deviations that can happen because there's no events being emitted. So there's no risk of, there's no permutations of what events could come out.
Yeah.
So it just basically gives a fixed point in time that everyone can start
Yeah.
moving forward from.
Yeah, it's all expected things that is happening here. There's no anyone else doing something from external. Yeah, good point. Okay, moving on. Yeah, this is the code. Basically, we're just appending the event.
Coffee break time.
Yeah, sorry. I'll try to finish quickly. I already talked about this, so nothing new here. Yeah, and you do have some primitives to make sure in your tests you're asserting it with events correctly. You can set some block number, more than one, and then you will see the events emitted. You have already these things like assert has events, assert last event. You also might notice that these are like feature STD, which means only for tests, not in your runtime. Yeah, and then there's like assert has event, last event, which you can use to test that your expected event is emitted correctly. There are also few fun things or fancy things you can do. When I look over or show you the code, remind me to like show you some palettes how we check for or filter for some palettes specifically, and not like, so basically when you're looking at these events, it's on whole runtime level, and you're doing something, but some other palette can emit some events. So that means sometimes you might not see the expected result that you think because there are other events. There are cool ways you can actually filter out events by palette. Yeah, some ways to test, good to bookmark, and maybe when you're actually writing these tests, you can refer to it. And let's see if we covered everything. Yeah. So yeah, that concludes events and errors. I hope you understand at least big picture what are events and errors. From after the break, we will start trying to understand how this construct runtime works and how they create these enums that I was talking about. But this should at least give you a high-level idea of what frame is. Any questions before we go on a break?
Let's do them after the coffee break, huh?
Sorry?
Let's do them after the coffee break.
Yeah, questions? I mean, I'm here, so you guys can ask me anyways in the outside this stage.
Nice, 10:36. Okay. So you were seeing, is everything all right now? Nice. Okay, so you were seeing before the break with Ankan, you first saw what was Substrate, a little recap, then what is Frame, a little introduction, and then you dived a little bit into how you structure Frame palettes. What are palettes? What is the runtime? What are palettes, which is these modules inside of the runtime? And then how you build a palette. So what components does a palette have? It has the calls, which you saw. It has the errors and events. And now we will look into origins, which you saw a little bit. This will be more in depth, and any questions you might have about origins, which is one of the, I mean, it's all very different from smart contracts. I know a lot of you might know smart contracts already. And a lot of things here are different, like somewhat different to smart contracts. So they are somewhat also similar. So for example, a palette has functions you can call. It has storage, it has events, it has errors. It pretty much looks like a smart contract. But it's somewhat different in somewhat subtle ways, like all of the, like palettes are not independent entities in your runtime. Your runtime is just a collection of palettes. We only have the concept of a palette because we want to modularize things and make things reusable. So one palette, for example, the balances palette, which allows you to have like a token, can be reused on my chain, on your chain. Anyone can use the balances palette. And that's why we also have this other concept of the config that we don't have in smart contracts, where one same palette could be configured in different ways depending on where it's running. And then there are lots of many other differences, but the origin is another one of those differences. It also suffers from the same issue where it is kind of similar, but kind of not. So we'll talk more about this now. But hi, everyone, by the way. I'm Francisco, didn't introduce myself. I don't have anything to introduce myself. But I will be talking about origin. And over the course of this, I'll also mention some other things that have helped me navigate the Polkadot SDK codebase and Polkadot in general, and Substrate, XCM, and all those things. So this I already mentioned, that we will cover the use of origin in Frame, how to actually, so what's the simple things you can do, like what it is, what's the simple things, why you use it, and then also some more advanced things like creating your own origins, basically doing account abstraction on Frame. And then all the references are, there's a reference in the Polkadot SDK docs. I believe you have access to these slides, so this should be a clickable link. Yeah, it should. So those are the Rust docs, but they are specifically made to as a sort of guide or a thing that you can read at your own pace. So what is an origin? Let me dive into what is an origin. So this thing right here, remark, is a call, right? You've seen those before already. This is the function that we can call from the outside world into our palette. So our palette has a lot of things, some of which are calls that you can access from the outside world as an extrinsic. So this, we would say it's a call. Anne can mention the difference briefly, but how I see it, all of these functions, they are calls. They are also dispatchable because they can be dispatched. And the act of dispatching, the act where the runtime executes the thing, it's called dispatching, a call. But the thing that someone submits is an extrinsic. And as an extrinsic, it's just a sequence of bytes that has a particular format. The extrinsic might include things like the signature, like it includes much more things than just the call. And the extrinsic itself has the index of the call, which we mentioned before, someone was asking, has like a byte for the palette index and then a byte for the call index. So all of that goes into the extrinsics. So just to mention how I navigate through this like extrinsic versus call. So usually these things are calls. So this function remark, this call remark, comes from the system palette, which is this palette that has a lot of baseline functionality and defines some of the things like account ID or things you will use all over the place on your runtime. It is a palette that we require every Frame runtime to have, just because it has such important low-level functionality or like base functionality. So this call remark takes an origin, which is this origin 4T, which might look weird to you if you're not into Rust a lot. But we can talk about that later. It's a type alias, which takes a generic T. Does anyone know what this T stands for already, or have we not mentioned that? Yeah, someone over there. The what, sorry? Generic type. Yeah, it's a generic type for sure. But do you know what's the usual concrete type for this type? Have we covered that at all?
I think usually it's like a type that implements config, if that's what you're asking.
Well, there we go. That's great. So the type that you usually, so this T you will see on your palettes, you will see T everywhere, and it's one of the most like asked questions or sources of confusion. It's a type that implements the config of your palette. It usually is the runtime itself. So this T will be the runtime, and all of the palettes that you're using will have access to the same runtime because the runtime implements the config trait for all of the palettes. Nice. So yeah, this T is your runtime. So depending on the configuration of your runtime, which is the configuration of a lot of different palettes in your runtime, you might get different things. That's why we have this T everywhere. And then the remark is just like a string or a vector of bytes. So remark just puts a string in a block, and it leaves it. It doesn't do anything else, but it means you put something on chain, and it will always be there because you put it on a block. You put it in the parameters of a call. Every call you see on a pallet will, maybe there might be a reason why not to, but most of them will have one line at the beginning that it says ensure something. It would be either ensure signed or root in this case, ensure none, ensure something. So first you do like a privilege check, right? Like an access control check. So in this case, ensure signed or root. So this origin is not an account ID. For example, in smart contracts, you get an account ID, or you do message.sender, and you see the account that it came from. Here, Substrate and Frame make it very generic. A call doesn't need to be made from like an account. It could come from another part of the system. It could come from many other different sources. So it doesn't even need to come from an account with a traditional signature. It can come from an account with a specific signature, with a different type of crypto, with a zero knowledge proof. You can do lots of different things with that, which we can talk about more, or we will talk about more, I think, on the transaction extension lecture that will be given afterwards, sometime in the week. And then you grab this origin and you ensure that it is either, like if it's a signed origin, it means it's an account with a signature. So you can treat it as a regular account. But it can, in this case, be root. So the root origin can come in and call this function. Anything else that is not signed or root will immediately throw an error. So a dispatch result, a dispatch error, as you see, and it will roll everything back. So the first thing you do is you check the access control. If they cannot access it, then you go away. And you don't need to do further processing, right? So this is the raw origin type. This is like the origin type that we provide that is very simple. It just has the root origin. So the system itself wants this dispatch to happen. This is the highest privilege of them all. So it might be like sudo, or it might be like governance, like there was a referendum. Most people said yes, so we execute with root. That's how you might get this origin, and we will talk about how you actually get this origin to put it in those parameters. Then signed, as you see, it has been signed by some public key, and we provide the account ID. So this will give you access to the underlying account. So the account that has a nonce, that has a balance, and all those things. And if it's signed by nobody, you can actually require that your call is signed by nobody. It might seem weird at first, but it can be either that it was included and agreed upon by the validators anyway. So for example, there is no origin, but the validator that is building the block has to put it in, else it's invalid. So you don't need to do any check. You know it's the validator that put it in. So that's why you don't need the validator to like submit a signed transaction. It just puts it in the block. That's why you don't need the other levels. And then, or it might be an unsigned transaction validated by a pallet. The other thing you might do is not require any type of origin at all, but then the payload of the call will have, for example, a signature that is not the regular crypto. So that's why you don't use signed, which is automatically handled for you. You just use none, and then you validate from the payload of the call, you do some custom checking. So if you want to do your custom checking, you can use none. Of course, it's not usual that you do this. So you can usually you always use either root or signed. So this kind of is the whole basic usage of origins from the perspective of the pallet. So from the perspective of the pallet, you just have root and signed. Of course, in some exceptional cases, you will have none. Then we will see from the point of view of how, from the runtime, like how do you actually get this origin to put it on the pallet. And then there's some advanced usage, which we can talk about later. I saw some hand over there, some question. Do you still have the mic? No, there you go.
Is it a problem that validators can just include transactions in a block without having to go through any verification?
They only can do so with particular transactions that are already agreed upon by the protocol. So it's not like they can include anything they want. There are just some particular extrinsics that we call inherents, which we will see in this lecture, that they can include and they're expected to include. Right? So you can, when you design your protocol, for example, if you're designing your chain, your parachain or your solo chain, you can define what inherents are available. One inherent, which we will see, is the timestamp. So when you're building a block, you include the timestamp in of your own clock. And then people know that it's a timestamp and they know it came from you and it's like backed by the protocol, let's say. Good. Let me see some things. Okay, so up until this point, everything clear? The difference between root and signed and how this is different from like message.sender in smart contracts. So in smart contracts, you don't have the possibility of doing root. You don't have the possibility of doing like your custom validation of the signature, for example, or all of the advanced stuff we'll see later. Basically, because this is, you're building a blockchain, not a user level, like an application level thing. You're building the underlying infrastructure. So how is it used? So the runtime origin is used by dispatchable functions to check where a call has come from. This is what we've already seen. So every call takes one parameter at the start, which is the origin. That is pre-filled by the system. So you only care, like if you're designing a call, you only care about the things that come afterward. The rest is already there. So this is similar to message sender, but frame is more powerful, and so is origin. So you have access to a lot more things. If you just want something equal to message.sender, it's basically the signed origin. But again, this is not a smart contract. This is trusted code. You can do anything you want with it. This is one runtime. There are no issues of that sort. But I know it's hard if you come from that mindset to step away from it. So that's why we mention all the differences and similarities as well. So these are the origin checks. We've seen ensure signed or root on that remark function. So that ensures that the origin represents either a signed extrinsic or root. I think it goes to the side, yeah. Or if it was the root. Returns OK with the account that signed the extrinsic, or none if it was root, but it's still a success, or an error otherwise. That's what we've already seen. Of course, we have one for each of the other variants. So you can ensure that it's root. If you want to make like a palette which has a call, which should only really be called by the admin, you put root. Then we'll worry about how to create this admin, right? It's not like you have choices. Then ensure signed will be just an account, and ensure none means, hey, that there's like we don't know where this came from. You should be able to do some custom validation to know where it came from. Now, ensure none does not mean, okay, I have feeless transactions and I've solved the problem of fees and now no one needs to pay for fees. If you have an ensure none and then you do nothing, like it's not an inherent, for example, or you don't do any custom validation, then your chain is open to DDoS attacks, right, to DOS attacks. Because anyone can just call this and make you execute stuff for free. So you need to keep that in mind. So it's pretty much like an advanced thing to use ensure none, because you can shoot yourself in the foot if you put ensure none and you don't do the correct validations. If you use ensure signed or ensure root, that's basically you're covered. The system will guarantee that it was only root or a signed origin, a signed account that called it. And now examples. Let me give one quick example and then you can go. So we've seen this ensure signed or root. We can also have just an ensure signed, which usually you'll see this ensure signed. Like most of the time we just use this because we just want an account ID. For example, this is in the palette balances, which lets you have a token, transfer, so on, would be like an ERC20 token in smart contract land. But again, this is a palette. We have a transfer function. It has a call index, which we've mentioned before. It has the weight. And then it has some origin, destination value, a dispatch result, which every call needs to return. And then we do this ensure sign so that we get actually the sender of the money, right? Most extrinsics will use this. And you might see this and think like, okay, but this cannot be called by root, So isn't root the highest privilege? Shouldn't I be able to also call this? And there are ways where you can have, like you can create a call that returns the root origin, or a call that calls something else, or dispatches another call from the root origin. So you can have, we have a utility palette, which lets root bypass, like which lets root impersonate any other account. So then ensure signed also works with root. Root is not powerful in and of itself. It's powerful because we decide that if something is root, it should be able to do anything. So in our palettes, all the logic that is like should be is power user level code. We put ensure root and then just make sure that it can call it. There was a question down at the back.
Yeah, it's two questions. You partially answered one of them. It is about the hierarchy of this like authentication things. So root is in the top. What should be the next? It's signed or the none?
What should be the one that comes after?
Yeah, who's the, like with the highest privilege? It's
So-
root now. What should be like if we still have the signed and the none one?
Yeah, so root is the highest privilege for sure. But then it's not like they come in a hierarchy of who has more privilege than who, because this is a pretty simple distinction, right? We just say you are either the admin of the system, which again doesn't have to be one person. It can be like a referendum passed, so the will of the people. So you can be the admin, you can be just like a regular account, or you can be none, which is kind of like you can do custom validation on your own, or you can be an inherent. This is not a very complete like access control system. You can create your own origins, and when you create your own origins, you can create your own access control system with like a hierarchy and so on. So basically, and we will talk about that later, that's more like an advanced thing, but it's perfectly fine. So you can define this access control checks with origins, and we'll actually see that we do it in a lot of palettes. So here we just have a very like normal enum that has 3 variants. You can create your own enum, and we'll see how to annotate it right up top so that it is like the system recognizes it as an origin. And then you can add your own enum variants on that enum. And you can have like, I don't know how you would call them, but you can have like a hierarchy on those variants.
Gotcha. Like this is like also partially answered. The second question was related to let's compare it to the Ethereum things.
Yeah.
So in smart contract in Ethereum, we have the message sender, and also we have the message like the transaction.origin, which is tell me like the source of this call. And I'm wondering here we have only 3. So my question was like how like in cross-chain things, because in this case, if I have like a call from another contract, I want to like validate that this is from this user, and also this is the source, like who are calling me. How it's, I know like we have the it's called the XCM things.
Yeah.
So I was like thinking, do we have any extra like kind of items in this in this enum there, or it's only the 3 of them?
Nice. That's a very, very good question because, yeah, it points to the customizability of the system. So the main thing that this system does is abstract accounts from sources of extrinsics. So extrinsics can come from any place. It's basically like the account abstraction that like they are creating or were creating back then in Ethereum. It's like a poor man's origins. Like in origins, it's like built from the get-go that you can abstract the account from the underlying source. Like the source doesn't need to be an account. So you just create a new enum, and we'll see how in a bit, where you add new origins. And the XCM example was very good. You can create your own, but we have created like a custom origin, which is like a parachain. So you can create a call that is intended to be called by a parachain, not by a user, not by a root of the current chain, but basically like by the root of another chain. So there are ways by which you can know, like you have different levels of abstraction, right? At this level of abstraction, you just know this call has to be called by a parachain root. And then the underlying system will make sure how to actually assign the right origin. We'll also see how to assign these things, how to create these things. And then you know that your call can only be called by a parachain route, and you can do stuff like, for example, we have a very real example where we have a call that is like establish a channel, like a communication channel between two chains, and it can only be called by a parachain saying, hey, I want to connect to this other chain. As an example. Okay, we have another question over there.
This question, I think you might have to say yes or no, like as I go, because I'm not sure at what point I don't understand. So there is like a pseudo palette, right?
Yes.
And from what I'm thinking, like the root probably dispatches a call to the pseudo palette, which then makes another call. So like the pseudo, like the call from the pseudo palette is probably like an inherent. I'm not sure what.
Okay, now that's a very good question as well. Let me continue with the presentation for a bit, and then we'll see exactly how the pseudo palette works. I think it will give you a very good idea of how to use origins. And also that origins are just regular Rust enums. So you mentioned like that there has to be like some magic in there, like some inherent or something. And the truth is that it's actually really pretty simple. So we'll take a look at it. And that's basically how can one call dispatch another call and choose which origin to put in there. So that's just a little spoiler, and we'll keep on going. Okay, so we saw the origin checks. We saw the example. This is the example of root. So remember, you use root when you're sure that this has to be called by like the most powerful privilege. So in this case, set code sets the code of the entire blockchain, seems privileged enough. You do ensure root. And then you check if it comes at code, and then you set it, you call some handlers, which we saw a little bit. The T on set code, it's like on your config, you can set another palette. It's like a callback when you do things. So then you call this set code function, and it will actually call a different palette. Remember, all the palettes are just part of your runtime, so you can call them as you please. And then the non-origin, in this case, this is the inherent. So this sets the current time. This is in the timestamp palette. Again, like you can create palettes for anything. You choose how to architect your application. You don't need, like, if it's just one palette that has one call, it can still be its own palette, right? It's just a matter of separating concerns. So the timestamp palette is very, very simple, and it has this inherent. Now, the inherent has two bits. You have to put ensure none at the start, but you also need to do this palette inherent bit for all that part we talked about, that like the block producer will include it. So the system will only recognize that if you if you implement provide inherent for the palette. Here, there was a question before about what's going on with this palette struct. So it's just a regular Rust struct, but you unfortunately cannot put any variables in it. It would be very nice if you could, but we do everything in our power in frame. We do everything in our power to not have dynamic dispatch. Some of you might know what that is. It's basically like inheritance and runtime level code. And in this case, it would be dynamic traits and vtables. Some of this might ring a bell. So we do everything with types. And that means we have a lot of generics. That means we have this palette struct that doesn't have any fields, but it will have associated functions. So we implement a lot of stuff on this palette. And this palette struct, of course, it has the generic T. So it has to receive the runtime that implements its own config. And it will be, this palette struct is the thing that we use when we pass palettes around. Like when we have one palette and we want to configure it with another palette so that it can call it, we will give it this struct. We'll talk about this, of course, later as well. The other thing we can do with none, which I mentioned before, is we can do the validate unsigned. Again, this thing has to be annotated on its own way. Like just using ensure none doesn't give you either an inherent or a custom validation. It just opens the door for you to do one of those two things. This validate unsigned, I think this has been deprecated in favor of the transaction extension, but the idea is pretty much the same. So we will talk about transaction extensions in a later lecture, but the idea is the same. The idea is you receive an extrinsic that might not have a signature like all the other extrinsics that you get, and you do some custom validation. Maybe it has an Ethereum signature. and you validate it on your own code. Or maybe if there's some reason why they should be able to execute this, yes.
Just a quick note, when I was looking at the slides for transaction extensions, it's not deprecated yet. The plan is to deprecate validate unsigned. There is sort of replacement stuff in the works, but it's, yeah. So validate unsigned right now is more like marked to be deprecated.
Yeah, okay. Yeah, it is like, I believe you should use like the new thing if you can, but you can still use this. Like this is still valid code. It's not that it's not valid anymore. And you will see it around in the code base, so we're showing it to you. And the idea, like, yeah, it still exists. We have this transaction format. We have a new transaction format. There's another way of doing some of these things. But this will always be a way, or at least for the foreseeable future. But the idea is that one, right? Like, for example, before I move on to custom origins, which is the like more advanced stuff, I wanted to mention that like Polkadot's ICO was using this call, and this is something I remember. So I'm an alum from the first PBA, and I remember this being said to me back then, which I had no idea of, that Polkadot's ICO was basically, they made a palette which was a validate unsigned, because it had to receive a call that didn't have a signature, because there were no dots back then. So they had a smart contract on Ethereum where you could like get dot. You basically got like some rights to get dot. And then in the new Polkadot chain, you would send an extrinsic with your Ethereum signature in the payload, and then they will validate it on this code. Like it's unsigned, yeah, sure, it doesn't have like a Polkadot signature, but in the payload, I know it has an Ethereum signature, so then we validate it in our code, and then we check if we should give him dot, and we give him dot, right? Like that's, of course, this might not be the use case that you will implement, but it's one of the reasons why the system is flexible like that. Like not everything has to have a standard signature behind it. You can support multiple cryptos. You can do all sorts of different validations, like ZK proofs, which is something that we haven't seen, but you can do it in the sense of you don't need a signature. You just do some custom validation of why this should work. Okay. Now moving on to custom origins, which is this more like advanced side of things. Origins are extensible and customizable. Each palette can introduce new origins. So everything exists in a palette. So palettes are the ones that can introduce new origins, which means if you want to use any of these new origins, you need to implement that, like you need to include that palette on your runtime. And basically, you might have figured it out at this point, but we have like libraries full of palettes that you can reuse, like balances, assets, and some that just give you origins. They don't have any calls. They just give you origins, for example. So you mark them as palette origin, and you just define a struct. I actually thought it would be an enum, and I think it actually is. So never mind that struct on the other slide. But basically, it's an enum, as we saw the raw origin enum. Here we have another raw origin enum, but it's not the same one. It's not like the system. So the system palette, I think, is the one that provides this origin with this mechanism. Or it might be something that is like built into the framework, which is fine. Those are like the three basic ones. But here we have a palette called collectives, which lets you define collectives, sort of like DAOs, right? And you might want some sort of access control, like, is this extrinsic callable by just one member of the DAO? Or is it callable only if multiple members of the DAO call it, right? Sort of as a multisig. We also think we might have this for a multisig. Maybe we do not, but it's a perfectly reasonable way of implementing, like, is this from a multisig or is this from just one guy, right? So how you implement this is just a regular Rust enum. You put some variants, for example, members, and you include whatever you want, like whatever information you want in there. So for example, how many members? So I believe this is 2, because it's like how many from how many, like 3 from 5, right? Yeah, from a given total, like 5 members of this DAO, how many people have condoned this, or how many people have agreed to this? Or you can have a member, like it has been condoned by just a single member. And then we have this dummy Rust thing, which you will see every once in a while, which is just totally boilerplate, and you shouldn't care too much about it. So this is how you define custom origins. Now, of course, we haven't talked about how you instantiate these origins, but hopefully the idea is clear. You just define an enum, and you sort of define your access level privileges, and they can be anything you want. You then need to implement like how to actually construct those origins from the outside, but they can be anything you want. And then when you're implementing your palette, you just use them as what you thought them to be. Like you use them knowing already that some part of the system handled the fact that you got a members origin. And then you can have like an ensure members, which is not here. But remember how we had an ensure signed here. Remember how this ensure signed will return the account ID. So you can have an ensure members that will return the two, like the how many from the total. Like you can have this, you can make this custom things, which make palette code much nicer. And then this is an example which we talked about, the parachain origin. So this one is a very good one. We have a palette that I think just provides this origin, which gives you like a parachain variant. And then we have an underlying system that will create this origin for you when it is actually like a message sent from another chain. This separates the implement, like who can create, how you create the origin from how you define the origin. So defining the origin is very easy, and then you need to check like how to actually build it. So this is the parachain, and you get the parachain ID once you validate it. So this is very useful. Hopefully you can see a little bit of its power. And then let's talk about redispatching, which is one of the ways of like, how can I get this custom origins to work? How can I construct these origins? So these origins are just, let me take a moment first. Is this custom origin, where was the custom origin? Here. Has this custom origin thing been understood? Like how you create these custom origins? Yeah, one question at the back. Nice.
Like it's very clear, but it triggered one question which related to standardization with the other things. Do we have any kind of limitation or things to consider? Yeah, we have like a great tool, we can customize whatever we want, but like when it's come to interacting with other tools in the ecosystem, do we have any things to consider, to put in mind?
Yeah, so that's a very good point as well. And that's maybe one of the downsides of like Substrate and Frame is that you can, so one of the benefits of Substrate and Frame is that you can customize everything. One of the downsides is that you can customize everything. So like you can create your very own solution and it will be totally different from another guy's solution, and you maybe didn't check before that there was already a solution for that. And now it's not standard and you cannot, and you're just like speaking like two different languages. That can happen, but palettes are sometimes designed to be reusable. Like you sometimes create a palette and you realize that it could be generalized. Like you create it for your particular use case, but you might realize that you want to generalize it. So you start like generalizing some bits, like removing some of your custom code or custom assumptions, and you put all of those like generalizations on your config trait. So one of the processes where you might grab a palette for your use case and generalize it is by moving a lot of things to the config. Once you move a lot of things to the config, now this could be implemented by many different runtimes. Now, if that's the case, then the considerations of doing this would be make sure that it's useful to other palettes, make sure that you're doing, like make sure that you already checked, for example, that the palette doesn't exist or so on, or that you have good documentation of when to use this, right? But if you are implementing a palette for your own, or even if you're generalizing it actually, but these origins will most likely be defined on one palette and used by another palette. So we will see on the redispatching section, which we will see right in a bit, how like one palette constructs an origin and another palette has a call that uses that origin. So all of that should be documented in the palette. And then if you use all the palettes that like one creates the origin, the other one uses it, and so on, then in your own system, in your own chain, in your own runtime, then it's perfectly fine. Like you don't need to follow any standards with another thing if you're using your thing, right? I don't know if that explained it.
Yeah, it answered like partially part of my question. I mean, like for example, for the I can, if I have a parachain, I can connect. So I'm assuming from EVM, I can connect any wallet which is support this part chain. Whenever I have this customization in the row engine origin or stuff like this, in this case, I might have a problem to use these kind of like ready to use tools.
Okay, so tooling, yeah. So with regards to tooling, I think regards to tooling, it's more about transaction extensions. So the transaction extensions are the actual extra bits that you can have to the transaction format. So the transaction, or the extrinsic actually, is a set of bytes. And those bytes need to be known by wallets and off-chain tools, right? Okay, so that's like kind of the space where this lives. If you add a transaction extensions, yeah, you might like need wallets or tools to support you. However, these origins can work without transaction extensions. Why? Well, you can require like a signed account to call a pallet, and then that pallet will call your other pallet and will pass in the origin that you want. Like you don't need a custom transaction extension for that. If you do need a custom transaction extension, then yeah, adoption will maybe be a little bit slow on that front. But we will see an example now with like redispatching, which will also touch on the pseudo pallet. Like how does the pseudo pallet give you the root origin? And we'll see that it's pretty simple Rust, and you don't need any like complicated off-chain tooling to get it. So let's talk about redispatching. I think it will clear a lot of things out. So here we have the pseudo palette, the pseudo call. And then the pseudo palette just has like pseudo and a bunch of other pseudo-related things with different configurations. So pseudo takes an origin. Here we're highlighting the line that actually does the magic. But if you go to the signature of a function, you have an origin. As always, calls have origins. And you have a call. So you can include a call, which would mean the palette index, the call index, and the parameters, right? So it's not an extrinsic, it doesn't have a signature or anything. It's the palette index, call index, and then the parameters. You can include it on your extrinsic, on your call parameters, right? You can have a call that takes a call as one of the parameters. And then what you do, well, here we're ensuring signed, right? Any account can call the pseudo palette. Hopefully that's all okay by now. And then we have an ensure that says, hey, sender should equal this k, which is some key that I've defined. So the pseudo palette, what it lets you do is lets you register one account, which will be the pseudo account. And then that pseudo account can call this function, can dispatch this call. And I think that's why we have the difference between dispatch and call, because can call this call would be too bad. And then you can do this. The call, so this thing, this runtime call, which we will talk more about it later, you can do .dispatch. And I think this bypass filter, there's a dispatch without bypass filter, and there's the dispatch with. I don't remember what filter it will bypass. Yeah, I think the runtime has a set filter that it can filter things. You will bypass filters, and you will pass in the origin. So here is how you create the origins. So if you're in a palette, you can just import this enum, which is just a regular Rust enum, and you can pass any variant you want to another palette, to another call. So you have a call, you dispatch it, and you pass it whatever you want. Here you were passing frame system row origin root. So that's how the pseudo palette works. It doesn't do any inherent magics. It doesn't do anything off-chain or anything. It's just a palette that dispatches an inner palette with just a regular Rust enum. Hopefully that's clear by now. And, oh, sorry. And we could, instead of root, we could send members. So we have a palette that will figure out, right, by some possibly complicated logic, or possibly simple, whatever you need, it will figure out how many members you actually need. And then it will like construct the thing and pass it here, right? Good. So basically, palettes will construct origins for other palettes. So some palettes might define an origin. Some palettes might dispatch calls and put the appropriate origin and construct it however they seem fit. Of course, there's also the transaction extension aspect of it, which is like once you reach a call, so once you reach this pseudo, for example, you might have more information, which you gathered from the transaction itself. And that's a topic for another day. But even without that, you can have the pseudo palette, for example. So now you already know if you declare a palette and you put ensure root at the start. If you want, like if you're developing, right, you don't have governance yet. You just want the one developer to have the key, or maybe there's a multi-sig with all of the developers and they have the pseudo key. You just include the pseudo palette, and you know you can call anything on your chain because you have root. So you can call, like, I don't know, changing parameters, changing configurations, changing whatever you want. And then once you upgrade from being just like, I don't know, a little blockchain that you're developing on your own or with your team, you just move on to using another system to create root. So you just kill the pseudo palette, you don't have it anymore, so there's no more like one person or one team that has the control, and you use another method to get the root origin. The system, like this inner call, which might be anything you want, doesn't care how you get root. And that's also one of the advantages of the system. I don't know if you can see it, but it doesn't care if there's one guy which has the pseudo key, or if it's a referendum, which we'll see the referenda palette can get you root, which is a referenda that has been passed and can let you call this. When you're defining the call, you don't need to worry about that. So that's the separation of concerns. Oh, sorry about that. Here's an example from the collective palette. So I mentioned this before. You have this do approve proposal, which is when, like, presumably, this is not a call, right? Because it doesn't have the palette call thing. It's just an internal function, which might be presumably called inside of a call. You get the origin. Sorry, you create the origin members, and you see like how many yes votes you have and how many total seats you have. And then you dispatch a proposal with the origin, right? And then that proposal, so whatever that proposal is, which proposal has to be an actual call. Well, here it's called proposal. This is not showing, that's interesting. There you go. So it has to be an actual call. So this proposal is presumably a call. It's just probably aliased to proposal. It will be dispatched with the appropriate origin. And that's how you do it. That's pretty much how you do it. We have two examples now, the pseudo palette and the collectives palette. And now we can see, like, how do we do this amazing simple checks, right? How can we do ensure members or ensure parachain, or this, like, the checking of the origin. So now we know how we define the origin, how we construct the origin, how do we check it. So there's this trait, again, just basic Rust stuff. We have a trait called ensure origin, which is where you can define the custom logic. Called, for example, it will give you a function called ensure origin. But you can define with associated types, you can define like what's the outcome of the function, right? And you can, in here, add your checks to like members or any other sort of origin you might define. So this needs to be configured in the runtime, where all custom origins of your runtime are known. This is another example, the alliance palette. So the alliance palette, yeah, so here we're seeing how to configure stuff. And here we also see a little bit of that access check, like access control, right? We have a configuration for a palette, and we have an admin origin, a membership manager, and then an announcement origin. All of these are things that implement ensure origin with this self-runtime origin, which we will see later. So all of this need to be structs or enums, I guess, that implement this ensure origin trait. And what does this let you do? It lets you define a palette, and in the configuration you have like admin, membership manager, announcement origin, like different privileges. And then in the runtime you configure them with different implementations of ensure origin, which will check the actual origin. How do you use it? You just go to configuration, or as you perfectly said, you go to the thing that implements all your configs, which is T, which is the runtime, and then you access this admin origin associated type. This is a syntax that we use a lot, so you will definitely be used to it by the end of this academy. And then you call ensure origin, and you pass in the origin. So this is all the checks that you need to do to use your custom thing. And then you implement this admin origin however you want it to. For example, and you have different ways of doing it. It doesn't only need to be root signed or your custom things. We have like helper types. Again, this will be helper functions in a regular framework. Here we're using types. And if you ask yourself, like, why is there no variable here? Why is it all types and generics and instead of variables? It's because we don't want dynamic dispatch, pretty much. So it makes our code run faster. So when we implement the config trait for our runtime, things we have seen before, like you implement the config for your runtime, we need to specify these types, these associated types. We will use, for admin origin, we will use either of diverse, which can be either root or a proportion or of at least 1 out of 1. So just like if it's an alliance of only one person, if that person signs it, then we're good. Then the membership manager can be either root or a proportion of 2 or 3, of two of 3. Like if more than 2 people out of the 3 of the alliance want to manage their membership, they can. And then the announcement origin is at proportion more than 1 out of 3. So I know this is a lot for a lecture without any hands-on things about this, but this is how you define like your access control checks, right? Now you have who is your admin, who is your manager, who is your announcement, and you know like there are all these custom origins, like this ensure proportion at least that you can use. Yeah, and you can support multiple different origins. So you can actually make like one ensure origin that will accept either root or a proportion of people or anything else you want. And then fees. So the last aspect of this is fees. So fees are usually handled by some palette. Again, everything we handle on palettes. So there's this palette called transaction payments. Yeah, transaction payments palette, which will take a fee, but there is no signed origin. Like if there is no signed origin, you really cannot take a fee out of it because you don't know the account, and fees are like a concept for accounts. So what do you do if you're calling the pseudo palette, right? What do you do if the pseudo palette does require a signed origin, but then it dispatches an internal call with root? How does this call take a fee? And you should assume any transaction which is not a signed origin is feeless unless you explicitly write code to handle it, which means the call itself that is callable by root is feeless. But the pseudo palette is not feeless. It can be if you wanted to, but if it doesn't have to be. What it does is it will take a fee for itself, so all of the things that it does itself, and it will take a fee for the inner call as well. So basically, if you have a call that requires a signed origin, that call dispatches another call with another origin, and it can even do so like 1,000,000 times. You would expect the first call to take a fee, taking into consideration all of the computation that it's doing. Again, remember all of this like other calls that you're making it to your own runtime. So you know how much fee you should take. And you design your system so that it is not attackable. So you just design it in a way where you know it's sound. If someone calls this, you know they will pay for the compute. That good? Now we have some time for questions. So any last questions you have? Yeah, question over there.
Hello. Hello. Okay. Rodrigo here. I have a question related with the origin checks, specifically with the ensure sign function. I'm aware that the Substrate chain support different signature schemes such as Schnorr, ECDSA, EDDSA. So I was wondering if there's like one specific signature scheme used by default, or how do we ensure the signature from the given origin, if we don't know which signature scheme is used beforehand, because I assume that inside it's sort of validating that the signature belongs to that origin, right?
Yeah, it's a very good question, and it has to do with this separation of concerns. So for example, some people assume that if you're doing this origin check and you're ensuring it's signing, some people assume that this function is checking the signature, right? This function is not checking the signature at all. That was already checked before. So as we saw, this pseudo palette, for example, can call and dispatch a new call with the root origin, right? And that's how we get these custom origins. Like we need someone. At the end of the day, all of the interactions with the outside world are via users. And not necessarily can be via a parachain, right? But at the end of the day, someone initiates the action. Although it can be a hook. So it can be actually the system itself that calls itself. So that's why we have this like abstraction. But this ensure signed, all it does is grab this origin, which is an enum, and check if the variant is signed. That's all it does. How does this origin get to be a signed origin? That comes from the transaction extension stage. So we have like the palette stage, which is on-chain code, and we have the transaction extension state, which comes from the transaction pool, right? I think we mentioned a little bit of this in the fundamentals. So if you're a node, you have a transaction pool, and some people send you transactions, right? You keep them around, and you constantly check if they're valid. And we'll have a lecture specifically on this. But just as for completeness sake, you check the transactions to check which one is valid. And once it's valid, you can dispatch it. So in the transaction itself, you will have the signature. So once you actually dispatch it, part of the pipeline of the transaction extensions, the pipeline actually can change the origin. So it can do this same thing. It can grab the bytes, get you the account ID, and then it can keep on changing the origin. So what it does is there has to be one transaction extension, which is like check the signature. Although it's not a transaction, I think it might be built in. But that transaction extension, you can define whether you want ED25519, SR25519, Ketchak, or whatever. Ketchak is a hashing algorithm, but like ECDSA or any other signing scheme. And then it will give you a signed origin. So this call doesn't care if it was ECDSA, if it was ED25519, or even it doesn't care even if it was like, I don't know, some ZK proof that at the end of the day gave you a signed origin. This signed origin could actually be like something that isn't even a signature at all in common terms. But what this function requires is that it acts as a signed account, right? So as long as you can get a signed account, and that's up to you, again, you're designing your runtime, so maybe someone creates a palette that returns a signed account, but doesn't actually check the signature at all. That's like very bad, and you wouldn't want to use it in your runtime. So everything that you're doing on your runtime, you should do it consciously. If you import a palette from somewhere else, you should audit that palette. All of the palettes that we have are audited and production ready and so on. But yeah, you can do whatever you want. But at the end of the day, the underlying assumption is that a signed origin had to have like some signature check. But it could be any signature check. If you care, for example, if you care if two transactions come in, one has like one type of signature and the other one has another type of signature, you would implement like a custom transaction extension, which would call your function, which cares, so it wouldn't call it with a signed origin, it would call it with like one of these signatures. And when you do this ensure origin that we saw before, it will return like the account and the signature, and maybe you care, right? You can design a system that cares, and you can do it in that way. Hopefully that explains it a little bit better.
Thank you.
You're welcome. Have another question down there.
So you were saying that like the call from the pseudo function, it is the one that incurs like the fees for whatever work it's doing.
Yeah.
And so it passes it back to the person who made the call to the
passes what back, like the fees?
Yeah.
Yeah, so the fees at this point in time, so not just for the pseudo palette, for any palette, at this point in time, fees have already been charged. Why? Because there's like another palette called transaction extension, blah, 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 called transaction payment, which will have an extension that will charge for fees at the, like when pre-dispatch. So before this is called, the fee will be charged. And how does this palette tell like the whole system how much fee it should charge? It is on this weight up top. So some people have maybe asked questions about this weight thing. This palette weight, if you see it accepts a function like a block of code. It doesn't need to be a number. Usually, like sometimes it's just a number. Like you'll see it as being just a number sometimes, but sometimes it's a function because it has to account for other things. And this is where the magic happens of taking into account the inner call. So if you see this, you create a variable called dispatch info, which is the dispatch info of the call, of the internal call. So this, if you choose to put a function here, it has access to these parameters. We will, of course, talk about that in the benchmarking lecture. But then once you get the call, you return the weight of the call and the class of the call, which I think we'll talk about at some point. But you basically return the inner. So it actually, I think it doesn't have any weight of its own. It just uses the weight of the inner one. In theory, it should have like some weight for this and this, but it's very minimal, right? But in theory, you should have like some weight. This weight should be the weight of the of the boilerplate, like of the before and after, and the weight of the inner thing.
This might never actually happen. Like if a pseudo function called itself, would it like recursively pass that?
Yes.
Okay.
And you can, although remember, if a pseudo palette calls itself, the next time it calls itself, it will have an origin of root, and it actually will fail because it checks that it's signed. But there's a palette which I might actually show you in a bit, maybe after a break, because we've been running for a while. There is actually a palette that is called the utility palette, which just has like a bunch of things that we didn't know where else to put, and it has a dispatch as call, which lets you, like, if you're root, you are assigned origin. You're any signed origin you want. And actually, this is one of the cases where you can receive a signed origin, but there was no signature check at all, right? Rodrigo, this is for you. So there's a dispatch as call in the utility palette that root can call, and it will dispatch a call with any signed origin it wants. It's basically like root can impersonate any account, but there was no signature check, right? So that's one of the cases where like the signed, this ensure signed thing doesn't mean that you're checking a signature. And it doesn't even have to mean that. It's a separation of concerns. You are just checking that according to the system, this acts as a signed account.
So can you make someone else pay the fees?
You can make someone else pay the fees. And all of that magic goes via like transaction extensions, for example. But you can manipulate the origin so that you can get that. Yeah, over there. Do you have my idea?
I just wanted to clarify. The signature checking is actually not part of the transaction extensions.
Yeah.
It's part of the checked extrinsic, unchecked extrinsic kind of. It's part of core frame.
Yeah.
So yeah.
What I meant, so I'm not too familiar with the new transaction extension model, but what I know is that now it's perfectly valid to like not require a signature. Like before with signed extensions or with transaction format 4, before it was like you were either assigned the transaction and you had a signature, like whatever signature your system had, like ED25519, SR25519, or ECDSA, or anything else. And you either had a signature or you didn't. And then if you didn't, it had to either be an inherent or a validate unsigned, which we saw. Now it's perfectly valid to like not have a signature. So I believe it has to be like some sort of extension, like we generalized that, so it's not part of like the core, but it's still like there, it's still built in, but you can do other things, like for example, instead of a signature, you have a ZK proof, right? To allow those things to happen, the system was made more general. Yeah, you know more about this.
It allows more origin transformation as part of the transaction extensions. That's true. I just wanted to clarify on the signature verification.
Yeah, so you have like signature verification built in on the like transaction level, But you can also do these things, for example, where it's not the pseudo palette, it's the utility palette, but you can call it with a signed account, with a signed origin. And yeah, you can do more origin manipulations with the new transaction extension system. Let's see. Utility palette. Let me look at the utility palette. That would be a good example for you all. So I'm gonna break my neck trying to do this without mirroring for some reason. Master substrate frame. Utility. There we go. So I already memorized all the different paths and because it's decay. You don't have to, but know that at the top level you have. I take this from out of Sean's book. I take this page out of Sean's book that he doesn't use an IDE because Rust Analyzer is too slow and he just knows where everything is and does Control F to find stuff. And honestly, once you do it, you're pretty fast with it. It's kind of like Vim. Like before you use it, you're slow as fuck, but then you're very fast. What?
Can you zoom in a little bit?
Yeah, zoom in. A good idea. Okay, so you will see a lot of live coding. You will see how each of us go through the code, and that will hopefully give you an idea of how. Of course, practice makes perfect, and that will give you your own way of exploring the code base. Sometimes I wish I had a go-to definition, but then my battery life thanks me for using my brain power instead of my battery. And practice, lots of practice. So we have this utility palette. So at the top level of Polkadot SDK, we have this folder called Substrate, which has like all of the Substrate things. And the ones we are interested in right now is Frame. So inside of Polkadot SDK Substrate Frame, we have all of the palettes that we have developed as parity and that have been audited, that have been used, and you can use for your projects. You just need to grab them, configure them. These are the Legos. Like this frame folder is the Legos that we mentioned. So you have alliance, asset conversion, asset rate, asset rewards. Some are totally like dumb, maybe, and you wouldn't want to use them, like glutton. Well, glutton is actually might be useful, but insecure randomness collective flick, maybe you don't want to use it. But some other things you might want to use. For example, you might want to use asset conversion, and you will instantly have a DEX, right? You just need to configure it the right way, and then set your genesis state, or just like seed it some data, and then you're done. So that's very, very useful. One of the palettes we have here, as you already know, is the pseudo palette, which we already looked at. I think in the interest of time, I will run out of time if I do it. So we will not look at the pseudo palette, but I really, really want to look at the utility palette. So the utility palette answers one question that I know some people might have, which I already alluded to, which is, wait, but can root not run things that say ensure signed? So utility has some things that let you do that. So if we go to source, maybe it's not actually utility, the one that lets you do that. Maybe it's actually pseudo. Okay, let's look at the calls. So when you enter a palette, how do you find the calls? With Command F or Control F. You search for palette, call, because we have that as the thing you need on your input block to get the calls. If you need errors, you just search for error. If you need storage, you just search for storage. And if you have an LSP and you have a symbol picker, you can find them very easily. Then we have this batch, which is very cool. It takes not only a call, it takes a vector of calls. So you can actually like send it a lot of calls and it will run them all in a batch. Right? So you pay fees, and here you see in the wait part, you pay fees for all of the inner calls. That's batch. Then we have this as derivative, which kind of like creates another derivative account using some number, not very useful for us at all. Batch all, like if one part of the batch fails, all of the batch fails. So just here you have examples of how you can use these things. Here you see like call this batch bypass filter, right? And you just clone the origin you're given. So you're not constructing a new origin, you're using the one you already have. That's something you can do. And then we have this batch as. There we go. This is the one I wanted to show you. So this one does very simple things. Ensure root. You need to be root. Then it calls it dispatches the inner call as the origin you said you want it to be. It's not even an account. It can be members, or it can be parachain. It can be anything you want. So root can act as anything, is this thing, right? And then you deposit an event saying, hey, I dispatched it. And here, as you see, if you dispatch something, it doesn't forward the error. This is something that I mentioned. You can implement things in a way that is maybe not the best one, but you can do like, here I called the thing, and I got a result. But I never, like, there's no question mark here. I never returned the error. So if the inner thing fails, the outer thing still succeeds. And I get an event saying, hey, there was an error, but as far as this extrinsic is concerned, or this call is concerned, everything is okay. So this might be something you want to do, or maybe something you don't want to do. In this case, I find it quite odd, and I believe, give me a second. I need to go to the end. Yeah, we created this thing called dispatch as fallible, which is almost the same as dispatch as, but forwards any error of the inner call. And this one, as you see, actually has a question mark, meaning that the thing that you're calling, if that errors, then everything errors and everything gets rolled back, right? If you're using this, please use this one. I think it's much better than the other one. Actually, it's very new because we only realized this recently, so you might not even find it. Just know that that's there. So just know you can implement things however you want. This, I think this would be more like a best practice. Good.
So can I add some?
Oh, yeah, please.
I mean, I think this is true, but correct me if I'm wrong. Every call runs in its own transactional layer.
Yeah.
So even if the error is not propagated,
okay,
the call that failed, that would not do any storage changes.
Yeah, okay, yeah, good comment, because that wasn't the reason why I find this like not a good practice, but you might have thought that, so good comment. The reason why I don't find the alternative that doesn't return the error as a good practice is because the tool that's actually calling it is like, yay, it succeeded, and it didn't actually succeed. And so for off-chain tooling, it can be an issue. For the state, you're right, every call runs in its own transaction layer. That's a very good comment. Thank you for that. Good. Then I wanted to mention something else before we move on to the next lecture. Yeah, so some knowledge, some things about what we will cover in this module, because some people have asked, like, will this be covered? Will this not be covered? I don't have a list to show you, but we have talked about calls, we have talked about errors and events, we have talked about origins. We will talk about the outer enum right now. I'm going to talk about it. Then we will give you like tips and tricks of how to use Frame, like how to in practice use Frame, like what are the best practices that we use, some tips that you can use. Then we will talk about the storage. How do you access storage? What are the APIs that we give you? We will talk about construct runtime, so how you amalgamate or join all the palettes on your runtime to actually form one unified blob. We will talk about how to test, which is what you will have to do a lot. We will talk about how to interact with tokens, with these fungibles that we have. So how do you mint tokens, how do you transfer tokens, and so on your code. We will talk about hooks. How can you get your chain to automatically, like on a schedule, execute things, like on the start of a block, at the end of a block, and so on. Every 30 blocks, whatever you want. Then we will talk about benchmarking, which is how to get this magical, where's my mouse there? This magical weight value, which will in turn be turned to fee, right? And then we will talk about all this transaction extension and transaction pool stuff that lets you do very cool things about, like, for example, sponsoring another guy's transaction and so on. And then I think we will also talk about migrations. All of this in this module, just so you know, if you have any question about any of these topics, know that there will be a lecture on it. Good. Just a quick update on that front. And then just something that really happened to me when I was a student. It was given very fast before the break, but there are no events at Genesis. And that's very important because sometimes you can have that bug that you don't see events and you need to check the block number, and you can actually like print the block number. Just wanted to mention that. Okay, so let's go to outer enum. Okay, outer enum. Let's go, and I have a hard stop in half an hour, so let's see how fast. I mean, let's just do this. I believe I need this guy. Okay, so we've talked about calls, we've talked about events and errors, we've talked about origins. All of these things seem to be defined in palettes. So the palette seems to have everything, like it has its own calls, its own storage, its own, like it has everything. But then we have a runtime, which is a collection of multiple palettes. So how do we actually know? And we mentioned this a bit on the call level, like we have 1 byte for the palette index and then 1 byte for the call index. So, okay, that makes sense. From the outside world, you send this, and then with the palette index, the runtime can actually choose like which palette to call. And then from the call index, it can actually choose which function to dispatch, which call to dispatch. That makes sense. But how does this work? And is it the same system for origins? Like, do we have like a palette index for the origin and then like an origin index? So how does all of that work? And all of this has the same system called outer enum. In a nutshell, all of these things are like an inner enum on each of the palettes. And there's macro magic that generates one single huge outer enum that each of its variants is a palette, and the thing that is inside is the palette enum. That's basically in a nutshell. Now we'll talk about what that actually means. This is also known as aggregate types, and there are many more than just like call, enum, error, call, error, event, and so on. So enum is, well, you've seen 4 of the main ones. It's like the call enum, the event enum, the error, and the origin. All of these ones have a representation in some individual palettes, but also the final frame runtime you develop has to have like a list of all the calls, a list of all the things that it has, all the events that it can have. So breaking it down, this is without Substrate. And this actually is like a huge code that you can, if you want, take a look more in depth on your own time, because you have the slides. But basically, this is without Substrate. So this is just a Rust thing that you can do. Like if you have multiple enums, like get a bigger enum. So let's say we have things that we, in Substrate world and in frame world, are very useful or known, like you have an account ID, a balance, and hash type. Then there's a balances module, which would be like a balances palette. And this thing has a call, enum. It has 2 calls, transfer and transfer all, right? This we've seen. Has an error enum, which has 3 errors. This we've seen as well. And it has an event enum, which has just an event, right? Then we have another module called democracy, which has the same thing, has some calls, some errors, some events. Then we have a staking module. You can see how this Rust file looks like a runtime. It's the same idea. These modules would be palettes, and then the runtime needs some way to access the individual calls, events, and errors. Yeah, and we have this dispatch error. What, sir? What about the slides?
Click the slides.
Click
the arrow down, it will go through them.
Oh, sorry about it. Yeah, my bad. Okay, you have this, you have this, and you have this. Thanks, my bad. And then you have this runtime primitives. So this would be something similar to SP runtime, which has this like, okay, modular is actually like a palette and the error. And then the dispatcher is either bad origin or the modular. So you see, you can always have, in your palettes, you can always have this bad origin error. If you fail on the ensure origin or ensure signed, if you fail there, you will get this bad origin. You don't need to define an error for that type of error because it's known, it's common. Okay, and then we have a runtime. In the runtime, we have this palette index enum, which is like, okay, we need to put all of the palettes on different enum, on different indices, so that we can refer to them, no, definitely not by name, so we can reference them. Then we create this outer enum, which is runtime call. So you'll see this runtime call, runtime origin, runtime event all of the time, and it's this outer enum. So it's an enum that has 3 variants, one for each palette. And then inside of each variant, we have the actual enum, like the inner enum, from the palette, right? So if we wanted to construct a call to the balances palette, like call number 1 on the balances palette, we would call runtime call, balances call, and then transfer all, I think it was. Then for runtime event, we have the same thing. And then we can't just have this enum and that's it. We need like some conversions from one enum to another. So here we're implementing like from a runtime event, which is the bigger one, to a regular balances event, like the inner one. We return that it's a balances event and we pass self. Like we can always move from the big enum to the inner enum. Sorry, we can always move from the inner enum to the outer enum. We just encapsulate it, we wrap it on the palette variant. And then, but you would need to do this for all possible inner enums, right? So that's a lot of boilerplate. Then you would also need a try from, because you cannot always go from the big one to the smaller one if it's not like one of the correct variant. So you would need to implement also this for each of the enums and each of the palettes. And this also explains how all the different runtime types are generally encoded. We mentioned like how things are encoded on the errors lecture. We now see that like it's not like the democracy call. It's not just democracy call. It has this wrapper around it, and that's why when we encode it, we actually get first the palette index and then the like inner enum index. So for example, here we see a lot of calls. The first one is the democracy one, right? And the second line that is highlighted is the outer enum that contains the inner enum of the first one. So it's the runtime call, which has the democracy palette variant, and inside it has the actually democracy call. So if you see below, the palette call, the first one, would be a 0 and then a lot of 7s, which is, I think, yeah, just proposed because it's the first element on that enum, and then a bunch of, like a hash that is all 7s. So that's why it's all 7s. Then if you see the runtime call, it will be a 1 because it's not the first palette, the palette at index 1, and then you will see the inner enum. Right? Because enums in scale, which I believe you covered, are like the variant and then whatever is inside of it. Then if we see the palette error, we see like staking error would be just encoded as a 2. But the runtime error will actually be encoded as a 1, a 2, and then a 2. Why an additional byte? The first one is the palette, although this one, if it's staking, yeah, but then we have the module, like in the list of all possible errors, there's the bad origin, there's like numerical error, and there's the custom error. So we need to point to the custom errors, and then we need the actual error that you define. And then in palette event, we get like a balances event, but then we will first need to go to the palette, right? So this is how we get all of these enums. Now, this you don't need to write by hand. We have macros which create it for you, so you don't need to write this boilerplate. So this is a real runtime. Let me finish with this, and then I can ask some questions. So in a real runtime, yeah, we actually used all of this. Let me see if I need to scroll a bit now. And the results are like this. So everything is as it works here. Like there is magic to not, so that you don't need to write these enums by hand, because it would be a lot of work. But it pretty much works like this. Like it's just an outer enum, and then all of the variants are the different palettes, and then when you go in there, you will have the palette enum. That's also why a palette can only have 256 by 256 calls, sorry, runtime, because you have 256 pallets in the outer enum, which is the variance, which you need a byte to select. And then when you go into one of the inner enums, you get other things. And then the path for using outer enums can be a bit confusing. Yeah, this is how to actually use them, which if you don't know, if you're not that used to Rust, might be a little bit difficult. But let's go with a couple of questions. Yeah. Sorry, at the back first, because she had her hand raised first. I don't know if there's a mic near her. Nice.
Thank you. Like it's kind of multiple questions, if it's possible.
Okay.
For the palette index, is it auto-generated or I have to like explicitly like set the indexes? And if in this case I'm adding, like what would happen if I change the index whenever I'm upgrading or whatever?
So the first question is, do you need to explicitly put the index? I don't know if you have to, but we encourage it. So the way of putting palettes in your runtime and putting the indices is with the construct runtime macro, which we will see later. And we encourage that you put the index. Why? Because so that you don't mistakenly change it. And that goes to the second question. If you mistakenly change the index, you basically break all of the off-chain applications that are calling your runtime. It depends. Like maybe if you change an event, no one was using the event, it doesn't matter. But if you change a call, it can have disastrous consequences where one, an off-chain application might send the call and it doesn't compute because maybe you change it and now the palette doesn't exist, so it fails. But maybe it points to another palette, like maybe you change the palette at a particular index. And so maybe the call is actually valid, but it doesn't do what it's supposed to do, and that's terrible because the people don't know it actually broke, and everything broke. So basically, if you want to remove a palette, don't remove it, mark it as deprecated, and tell everyone to stop using it, and add the new palettes. You have space for 256 palettes, so you have enough space to add the new things. Always keep things backwards compatible so you don't break existing applications. Yeah.
My second question is also related to the indexing things or like the palette thing. I'm just wondering because I saw like when you have the palettes and then you are adding these palettes in the runtime call struct, do I have to do it to all the palettes I'm using, or it's up to me to select? It's kind of like, those kind of palettes I want to use. This is how what like my assumption about it. Those palettes, they have some kind of like public dispatchable functions, and I want out of the box to be enabled in my parachain.
Yeah, well, so you don't need to manually write all of this glue that glues all your palettes together. And you can actually like get a palette and decide that you don't want the calls from that palette. You just want other things from that palette. And in the macro that like glues everything together, we let you do that. But yeah, it's basically things that you don't need to worry too much about. But of course, know that it exists for example, not making sure that you don't break the encoding, and yeah, that you know how this thing works, and you know what these types are, right? This runtime call, runtime event, and so on.
It's like partially answered the last question I have, which is like if I'm using this macro, if everything is like included, and if I want to kind of like exclude part of it, I shouldn't use this macro.
If you want to execute part of
Okay,
it,
if I want to customize,
yeah,
like kind of like override what's like the implementation of this macro, I shouldn't use it.
Well, yeah. So the macro gives you all the glue and gives you this system, and this is basically what we use in Frame. If you wanted to change something at this level, then you might have like a forked or different version of Frame, or you might choose to use something else. This is not how Substrate requires you to do things. So you can actually build a framework to build Substrate runtimes that is not Frame, and it doesn't use this convention. For example, that's what I mentioned when if you wanted more than 256 palettes, you could create like your tweaked frame that has more. Okay, one question over here.
Hello, Martin here. Can you turn back one slide to like, encoding? So is there a specific reason why runtime error always changes to U32 instead of compact, like the number?
You mean like because you have 4 bytes?
Yeah, we have 4 bytes.
Why is it not compact?
Is there a reason behind that?
I believe it's just because 4 bytes is not that much, and you can include it, and it's not too complicated to have it. If you have a compact, you could save on like a few bytes. I don't think it's that important. You could though. Yeah, you could, but I think in compact, you definitely could, but you will be saving like a few bytes. And yeah, I think you could, but it wouldn't be that important.
Wait, so the question was about the runtime error?
Yeah, so why the runtime error, the error can have 4 values.
Yeah, the reason is that we want to be able to allow for nested errors. We want to say like, okay, the XEM triggered an error that propagated in balances, that triggered an error that propagated in pseudo, that triggered an error that I finally saw. And so that the nesting of the 4 bytes here is about being able to do each one.
Yes, but he mentions why isn't it a compact?
But that's the thing. Like, one compact integer can represent, like, these are 4 separate bytes. So I can represent 4 nestings of.
I mean, you could in theory pack them.
I mean, but that sounds like some crazy.
I know, but that's the answer. So
I mean, the answer is that we are allowing for, like nested.
Yeah. Things. So we are allowing for nested errors, as was previously stated, and I actually have a good like practical example of this that I can show you. Probably not now because I will run out of time if I do that, but I can show you later if you are interested. Or I can share in the Discord as well. You could maybe do some crazy stuff where you compact them all into 1 byte, but actually no, it's 4 bytes. I thought if it's a U32, you can compact, like you can pack them all into 1. But if it's just 4 bytes, you might as well have 4 bytes. You could have something like the first bit tells you, but it would be very complicated. And then it would also restrict how many you can have on the first variant. So it would be like a very complicated system that you might be able to do, but we haven't because there's no need to like save up on all these bytes. Although in practice, these bytes are usually not used by many, but we can use them in frame. We have valid examples where you use them and they make lives easier. So they make front ends able to determine the error, and they can even like fetch the nested error, and they can see a whole picture of what went wrong. For example, you might actually, we saw the utility palette, you might have like this byte say like, if there was an error on the overall call, and this thing to be if there was an error on the inner call. Or sorry, this thing if there was an error, and then this thing is like the nested call error, right? Okay. So done with that, how do we use this? So this is one of the things where at some point in the academy it will click, all this relationship between palettes and runtime, because sometimes we define an inner enum in the palettes, right? We define a call enum in the palette. But then all of these individual enums get amalgamated into a bigger outer enum that then we can actually send as a config item into a palette. And that allows us to, for example, call from one palette, do things on another palette, because we have information about all of the palettes that are available. And that seems kind of magical. Like, how can we define something on one part, then get a runtime enum, an outer enum, and then pass it back in? But this is kind of the dance that we do. And it can be done thanks to Rust's type system, make sure everything is type safe. So example, here we have a trait, a config trait, so a palette that has a runtime origin type, a runtime call type, and a runtime event type. So this palette wants to know the actual runtime event. So it wants to know the events from itself, and all of the other palettes. And it can do that. You just need to receive something that can be converted into, a result, because it might fail, of the raw origin of this palette. Or it might be like self-runtime origin. Then the runtime call needs to be a parameter because you need to pass it in parameters, and then it needs to be dispatchable, and the runtime origin is the runtime origin. And then a runtime event needs to be able to be converted from my current event into a runtime event, and it needs to have debug and some other things. So you can pass these things to palettes. So if you want to access like events, which you shouldn't access events in palettes, by the way, because POV reasons. But if you want to like have the runtime call type, which we've seen in sudo, like you take a runtime call, you configure it this way. And it's basically just like this. You configure it, and then in the runtime, you just pass in this magic runtime call type that you will not see defined anywhere because it's automatically generated by the macro. If you're using construct runtime v2, you will see the definition of it so that you can like search for it. And then you just put it in the palette and then you can use it. So you can see now why we need to add an event associated type to each palette which uses events. So each palette that uses events will need to have this runtime event because the palette emits event. So it depends on the runtime's definition of the events, which also includes its own events, but that's perfectly fine. Okay, so now that we are here, let me actually show you. I actually have more time than I thought, so let me actually show you a valid example, if there are no questions. Let me show you a valid example of tree master polka.xem source lib. Let me show you an actual example of the nested errors, so when you might use them. So again, you can just search for palette error and you will see the errors. So this is a palette, it's called palette.xem, and it's meant, it has calls for doing stuff with XEM. So for example, sending a cross-chain message from one chain to another. And it has some errors, no? And it has like unreachable, like I cannot reach the destination, etc., etc. In some, we even explicitly mention the index, which you've seen this probably in the fundamentals with scale. So just to make sure that we don't break encoding, because changing this would also break encoding. And we used to have this error called local execution incomplete, which means, hey, the inner XEM program, which is like a program that you write that can fail for different reasons, failed. Like this error is just like, hey, it failed. And you're left wondering, like, why did it fail? Because it's like, it should be nested in. So then we added this local execution incomplete with error, which has nested information. And it has both an index, so where in my program things failed, and an execution error, which is like the reason why it failed. So this instruction index is 1 byte. So we have 1 byte, we have 4 bytes in total, right? So we have 1 byte for this enum itself, so for the variant. Then we have 1 byte for this index, so you will always know on which instruction, XEM instruction it failed. And then we have this error, which has leeway to be 2 bytes, so it can actually be either a normal error or a nested one that tells you what went wrong. So before this, a UI would just see, hey, this is failing. And after this, it would be like, hey, this is failing. And by the way, the nested error is this. Like that's what you would basically do. And you can do the same with anything that dispatches an inner call or that executes an inner thing that might error because of the various reasons. So that's why we have 4 bytes, and it's very, very useful. Yeah. So that's an example of how this works. And you could have this also in the utility palette or in the pseudo palette. I think we don't have it because it's not that relevant maybe, but that's why we have the extra bytes. And if you go to any, that's on that front. And if you go to any runtime, so if we go to Cumulus, this is a runtime. We're just looking at a runtime file, right? You will probably see this, which we'll see on a different lecture. We will see in depth like this construct runtime macro. But this is the thing that glues all the palettes together. Here, for example, you explicitly mention the index, so you make sure you don't change it and break it. And you also give them names. These names are aliases for the palette struct, which I mentioned was like the thing we can pass around. So we can send this name into a configuration of a palette if that palette wants to communicate with this palette. So at the runtime level, we can like send which palette can talk to which palette. So we do that, and then once we actually do this, like here we see like palette XEM and index 31, so on. Once we do this, this macro will automatically generate for us all of the runtime error, runtime event, runtime call, right? So we do not need to build it ourselves. This will generate all of the outer enums for us. So we just need to focus on the palette and then on the little glue, which is implementing in the runtime all the individual palette configs and then selecting which palette we're using and calling construct runtime, and that's all the glue we need. We need to focus on our development on like the palette level. We need to define inner enums and so on, and then everything else will be handled for us by this macro. And this is a frame thing, like the concept of palettes and this construct runtime is a frame thing. Good. Okay. So that's it for me. Any questions now? No questions? It's all clear? Nice. Let me see if I have anything else that I want to share. Oh, one thing that maybe we didn't. Oh, you have a question? Nice. There you go.
So if we were building a blockchain and we didn't need some of those palettes, we would just comment them out, as simple as that.
Yeah, so if you're building a blockchain, you don't need some palettes, just don't include them. If you like copy them, pasted code from another runtime, yeah, you can just choose which ones you want. I mean, if you have a blockchain that is running right now, like it's running, there are validators, so on, applications and so on, you shouldn't remove a palette because it will break a lot of applications. You should just like mark it as deprecated, tell people to stop using it, and then maybe include a new palette or so on. Or of course, you can remove it at some point if you want. Just make sure you're not breaking anyone. But if you are building your palette from scratch, then yeah, you choose which palette you want. Nice. Yeah, question here?
I just cannot remember. Did we say is there any maximum number of palette, or is it defined with memory?
There is a maximum number. It's 256, and it's defined in the transaction format. Like the transaction format, you need like 1 byte for the palette index and then 1 byte for the call index, and that's the reason why you can't have more. You could have more, and so if you tweaked the transaction format, you could have more. But then, yeah, you won't be compatible with a lot of tools that are compatible with like frame-based runtimes.
Understand. Thanks.
Yes, you're welcome. While you think of more questions, let me show you something in a palette. So this is a runtime. I wanted to show you a runtime. This is a palette. Okay, amazing. Yeah, this palette has like only one error. But what I wanted to show and share, I don't know if we mentioned it, but this document, this doc comment, which is defined in Rust, by having 3 slashes, is actually relevant. Like usually comments, I mean, this is also relevant. Like all of the doc comments that we put, I mean, this was maybe mentioned in the fundamentals, so I wasn't there, so I am not sure. But yeah, this documentation comments on errors, events, calls will be added to the metadata that is available to off-chain applications. So off-chain applications can read this and show it to end users. So when you're building your palettes, make sure to put doc comments that are meant for the user. And so because these ones will be shown. Most applications that are like compatible with frame-based runtimes will actually show them to users. So for example, if you want to share something like complexity, maybe this shouldn't be a doc comment and it should be just a comment, because this is meant for developers clearly, and developers can go to the code and see the comments. But a doc comment is like meant for users. Of course, it also makes sense to add it here. It's not that this is bad. But just know that all of this information will be shown to users, so it's very useful to have it, to have like a better user experience, like a better explanation. Yeah, one question over there, and it is the last question. Sorry, yeah. What's that?
It is markdown formatted, no?
Yes, I believe. Is it actually formatted? I think because it will be shown by some UI somewhere, they should need to treat it as
Okay,
Markdown.
okay.
But yeah, you can format it as Markdown. That's the thing is that's how it's usually rendered in Rust docs. Like it gets put in the metadata and it can be used, like it can be used in off-chain applications. But this is also good for you, like as a Rust developer. When you do cargo doc, it will open up like a web page showing you all the documentation of your things, and this will be Markdown formatted. Yeah. Then if on the UI they do show it Markdown formatted, it's up to the UI to decide. But yeah, you in general, for example, at the start of every palette, we usually have this like a title, and then links to the things which work like this, and then an overview, and an interface of how you can use it. And that's a very good practice. But we will talk more about best practices later. Okay, so we have a stop, but do you have a question or a comment?
Just logistical things.
Okay, so
Finish his end.
this is done then. We can move on to logistical things. Thank you.
You guys have already maybe seen the message in the Discord. The plan is to have to kind of publish the assignment this afternoon. So I think this was already said. I don't know. I was told, and you were probably already told that the afternoons are more optional than the mornings. But today we would ask you, it makes sense to be there for publishing of the assignment, so you can ask questions that come up directly and stuff. But in general, afternoons are more. You decide whether you come, and you might have already seen also in the schedule that the afternoons are more like exercise kind of direction. So we might talk, for example, I talk about benchmarking one morning, and then I have a benchmarking exercise in the afternoon. So of course, we think it's valuable. That's why we're giving them, but up to you whether you come.
Yeah, and they are optional exercises, of course, but they are very relevant for your assignment, which is the actual required thing. Nice. Okay, so I guess we go off for lunch. Okay, nice.